The clay is cool against the conservator's gloved fingers. Fragment K8538 measures barely 12 centimetres across, its surface carved with wedge-shaped marks arranged in radiating sections like a primitive compass rose. The British Museum's climate-controlled vault maintains exactly 18 degrees Celsius, the optimal temperature for preserving cuneiform tablets that have survived nearly 3,000 years. But it's not the age of this circular planisphere that troubles scholars who examine it, it's the precision. The tablet, excavated from the ancient Assyrian city of Nineveh in the ruins of Ashurbanipal's library, depicts the night sky divided into 8 sections. Within those sections, specific star positions are marked alongside cuneiform annotations describing their movements, their rising times, their positions relative to the horizon. When researchers at Bristol University applied computer reconstruction to the damaged portions and compared the star field to astronomical software calculating ancient sky positions, something unexpected emerged. The observations recorded on K8538 matched the night sky over Mesopotamia with remarkable accuracy, but the positioning of certain asterisms suggests the observer wasn't simply recording what they saw from one location. The angles imply calculations, triangulations, coordinate references that shouldn't exist in 650 BC, let alone earlier. This is not the only Sumerian astronomical text that presents this problem. The British Museum houses dozens of tablets covered in star catalogues, planetary observations, and celestial maps. The Louvre holds fragments of the Enuma Anu Enlil series, 70 tablets of astronomical omens. The University of Pennsylvania Museum preserves records from Nippur, the sacred city whose temple measurements were calculated using celestial alignments. Taken individually, each text might be dismissed as religious mythology dressed in astronomical language, but examined together, these tablets reveal something that conventional archaeological narratives struggle to accommodate. The Sumerians possessed a coordinate system. Not a crude system of the star rises here sets their observations, but a methodical framework dividing the sky into pathways, assigning specific stars to specific geographic regions, and recording these assignments across multiple cities hundreds of kilometres apart with consistent measurements. The Mull.apin Astronomical Compendium describes the sky divided into 3 ways: the path of Anu, the path of Enlil, and the path of E, each corresponding to specific latitudes. Modern astronomers recognise these divisions as representing equatorial, northern, and southern celestial observation zones. The texts don't explain why this division matters. They simply use it as an established system that readers were expected to understand. And then there are the city lists. The Sumerian king list, preserved in multiple versions across various museums, begins not with historical kings, but with 5 cities that existed before the flood swept over the land: Eridu, Bad Tabira, Larak, Sippar, Shuruppak. These aren't mythological places. Archaeologists have located 4 of the 5. They were real urban centres with temples, administrative buildings, and craft workshops. The texts record not just their names, but their sequence, their rulers, and most intriguingly, their relationship to the gods who descended to establish them. What if these weren't separate categories of knowledge? What if the astronomical tablets and the city foundation texts were describing the same thing, a pre-flood network of settlements established using celestial navigation mapped with precision surveying, and recorded in tablets that survived because they were copied and recopied through millennia, preserved in temple archives because they were considered sacred? The Sumerians called certain beings Anunnaki, a term often translated as princely offspring or those who from heaven came to earth. For decades, this phrase has fueled speculation ranging from ancient astronaut theories to purely symbolic interpretations of natural forces. But the tablets themselves use the term in a curiously specific way. The Anunnaki aren't described as creators in the abstract. They're assigned to cities. They establish measurements. They teach the arts of civilization through the Apkallu, 7 sages sent to specific locations. The language isn't poetic, it's administrative. Before you dismiss this as fringe theory, consider what mainstream archaeology confirms. Sumerian civilization appears suddenly, essentially fully formed, around 3500–3200 BC in southern Mesopotamia. The cities emerge not gradually but rapidly, already possessing writing, complex architecture, astronomical knowledge, mathematics, irrigation engineering, and legal codes. The Sumerians themselves never claimed to have invented these things. Their texts consistently describe receiving them, inheriting them, being taught them. They position themselves as preservers of knowledge that predates their own civilization. The flood narrative appears in multiple Sumerian sources: the Eridu-Genesis, the Atrahasis epic, the story of Ziusudra. In every version, the flood is presented as a dividing line. There are kings before it, with impossibly long reigns governing from specific cities. Then the flood comes. Then kingship descends from heaven again to different cities, and history resumes with more recognizable timescales. Mainstream scholarship interprets this as mythology or cultural memory of regional flooding, but the texts themselves never present it as metaphor. They describe it as historical transition, complete with geographic specifics and procedural details. What if the astronomical sky maps were actually site surveys? What if the 5 antediluvian cities represent a settlement network planned and established before the catastrophe the Sumerians called the Abzu, the Great Deep, swept across the land? What if the Anunnaki, whatever that term truly means, weren't mythological abstractions, but the Sumerian vocabulary for those who established the coordinate system their entire civilization was built upon? This isn't a question with easy answers. The evidence sits in museum displays and archival storage, fragmentary clay tablets covered in wedge-shaped script. Some of those fragments describe star positions. Some describe city foundations. Some describe beings who descended from the sky to establish order. The academic consensus treats these as separate categories: astronomy, history, mythology. But the Sumerians didn't categorize them separately. To them it was all part of the same story. Where are you listening from? What time is it there? Settle in, because we're going to examine these tablets in detail. We're going to look at what they actually say, what mainstream scholarship makes of them, and what remains unexplained. By the end, you'll have the evidence. What you do with it is yours to decide. But first, we need to understand the language itself, the script pressed into wet clay thousands of years ago that somehow survived when stone monuments crumbled into dust. The language written in clay. The Sumerian language died as a spoken tongue roughly 4,000 years ago. By the time Babylonian scribes were recording astronomical observations in the first millennium BC, Sumerian had already been dead for over 1,000 years, preserved only as a scholarly language, like Latin in medieval Europe. Yet the knowledge contained in Sumerian tablets continued to be copied, translated into Akkadian, and expanded upon through generations of scribes who considered these texts important enough to preserve with meticulous care. That fact alone suggests something significant about their content. Cuneiform, the writing system used to record Sumerian, developed around 3200 BC in the city of Uruk. The earliest tablets are accounting records, tallies of grain, livestock, labour assignments. The script consists of wedge-shaped impressions made by pressing a reed stylus into soft clay at various angles. Unlike alphabets that represent sounds, early cuneiform signs represented entire words or concepts. A sign might mean sheep, or grain, or sky, or God. Over centuries, the system evolved to include phonetic components, allowing scribes to write in different languages using the same script. This is crucial to understanding why Sumerian texts pose interpretive challenges. The same cuneiform sign might function as a logogram representing a word or as a phonogram representing a word. Context determines meaning. When we encounter a sign that can mean either God or sky or heaven, translation choices shape interpretation. The Sumerian word dingir, represented by a star-shaped sign, carries all three meanings. When the texts describe the dingir Anunnaki, are they referring to gods called Anunnaki, sky beings called Anunnaki, or something else entirely? The Sumerians would have understood the distinction intuitively. We're left interpreting fragments through multiple layers of linguistic uncertainty. The decipherment of cuneiform began in the mid-19th century when Henry Rawlinson copied the massive trilingual inscription at Behistun in Persia, written in Old Persian, Elamite, and Babylonian. Using the Old Persian version as a key, scholars gradually unlocked the Akkadian language, which shares the same script as Sumerian, but is linguistically unrelated. Akkadian is Semitic, related to Hebrew and Arabic, while Sumerian has no known linguistic relatives. By the 1870s, George Smith at the British Museum had translated enough Akkadian to shock Victorian England with a flood tablet from the Epic of Gilgamesh, a Mesopotamian flood narrative predating the biblical account. But Sumerian proved more difficult. The language has no modern descendants, no related tongues to provide clues. Decipherment progressed through bilingual Sumerian-Akkadian lexicons created by ancient scribes themselves, who apparently felt Sumerian was important enough to preserve even after it ceased being spoken. By the early 20th century, scholars could read Sumerian with reasonable confidence, though debates over precise meanings continue today. What emerged from these translations was startling. Sumerian literature is fundamentally different in character from other ancient mythologies. Egyptian texts are saturated with religious symbolism and metaphysical concepts. Greek myths read as dramatic narratives exploring human nature through divine allegory. Sumerian texts, by contrast, often read like administrative records that happen to involve non-human actors. The tone is bureaucratic, procedural, matter-of-fact. Consider the difference. Egyptian texts might describe Ra travelling through the underworld as a poetic allegory for the sun's nightly journey. The Greeks would frame it as a dramatic myth about Apollo's chariot race across the sky. Sumerian astronomical texts describe planetary movements with observational data, rising times, angular measurements, and predictive calculations. When they mention gods in these contexts, the references are brief, functional, almost incidental, more like noting who was in charge of a project than exploring theological meaning. The Epic of Gilgamesh, the Enuma Elish creation story, and the Descent of Inanna are dramatic narratives in the tradition we recognise as mythology. But these are the exceptions, the literary works. The bulk of Sumerian cuneiform consists of king lists, temple inventories, astronomical observations, mathematical exercises, legal codes, administrative records, and technical manuals. Even the mythological texts often contain surprisingly specific procedural details. The Eridu Genesis describes not just a flood, but the dimensions of the boat, the materials used, the specific cities involved, the sequence of events. It reads less like religious allegory and more like a historical account written from a particular cultural perspective. This matters enormously when evaluating what the texts say about their own origins. Sumerian civilization doesn't claim to have invented writing, astronomy, mathematics, or urban planning. Instead, the texts consistently credit these innovations to the Anunnaki or to the 7 Apkallu sages sent by the god Enki before the flood. The tone isn't reverential mythology, it's attribution, the ancient equivalent of citing sources. The Sumerians position themselves as inheritors and maintainers of knowledge systems they received from an earlier dispensation. Mainstream scholarship interprets this as cultural self-mythology, the Sumerians creating foundation legends to legitimize their institutions, much as Rome claimed descent from Trojan heroes or medieval European kingdoms, trace lineages to biblical figures. This interpretation has merit. Ancient cultures routinely attributed their knowledge to divine or heroic origins. The question is whether the Sumerian case fits that pattern exactly, or whether specific anomalies suggest a more complex situation. The archaeological record presents a puzzle that conventional gradualist models struggle to explain. The transition from pre-literate Ubaid culture around 4000 BC to literate, urbanized, astronomically sophisticated Sumerian civilization by 3200 BC is remarkably abrupt. Within a few centuries, southern Mesopotamia goes from villages to cities with populations in the tens of thousands, complete with monumental architecture, irrigation networks, occupational specialization, and administrative bureaucracies requiring literacy. This wasn't supposed to happen so quickly according to models of cultural evolution that expect gradual accumulation of innovations over millennia. Some scholars point to cultural diffusion, the Sumerians learning from contacts with other regions. But diffusion from where? No contemporary civilization in Egypt, Anatolia, the Levant, or the Iranian plateau shows comparable advancement at the same period. Egypt's own fluorescence into pharaonic civilization happens roughly contemporaneously with Sumer's, not earlier. The two civilizations develop in parallel, not in sequence. If diffusion explains Sumerian advancement, we'd expect to find the source culture somewhere. We don't. The alternative explanation, that development was rapid but internal, driven by favourable geographic conditions in the Tigris-Euphrates floodplain, has geological support. The rich alluvial soil, reliable water sources, and predictable flooding created conditions conducive to agricultural surplus, which in turn enabled urbanization and specialization. This is the standard account taught in every archaeology textbook, and it's not wrong, but it doesn't fully address why the Sumerians themselves never describe their civilization in these terms. They don't say we gradually developed agriculture, then cities, then writing. They say kingship descended from heaven, and the Apkallu taught the arts of civilization. Every ancient culture has origin myths. What makes the Sumerian case interesting is the specificity and the consistency across multiple text types. The astronomical tablets don't need to mention the Anunnaki, they're technical manuals, yet they reference the ways established by Anu, Enlil, and Ea. The administrative texts don't need to mention pre-flood events, they're bureaucratic records. Yet the king list includes antediluvian sections as a matter of historical chronology, not as preface mythology. The city foundation texts don't need to describe divine site selection, they're about real estate and construction. Yet they consistently credit specific deities with choosing specific locations for specific purposes. The tablets present internally consistent information across genre boundaries. If you're inventing mythology to legitimize your civilization, you don't usually extend the invention into your technical astronomy manuals and accounting records. You tell your creation myths in obviously mythological contexts, religious poetry, epic literature, temple inscriptions, but Sumerian texts blur these boundaries. The astronomical observations are precise and accurate. The mathematical calculations are correct. The geographic data is verifiable, and embedded within these factually accurate technical documents are casual references to the Anunnaki and the pre-flood antediluvian period, as though these were simply accepted historical facts requiring no special explanation. This creates an interpretive dilemma. Option 1. Dismiss all references to non-human actors and pre-flood civilizations as mythology inserted into otherwise factual documents, treating the Sumerians as unable to distinguish between history and legend. Option 2. Accept the technical accuracy of the tablets, while acknowledging we don't fully understand what the Sumerians meant by certain terms, leaving room for their perspective to differ from our categorical boundaries between history, mythology, and science. Most scholars default to option 1, which is methodologically sound, we should prefer naturalistic explanations over supernatural claims. But option 1 creates its own problems. If the astronomical data is accurate, the mathematics is correct, and the geographic information is verifiable, at what point did the scribes suddenly start inserting fiction? And why would they? These weren't poets or priests composing religious texts. They were astronomers, surveyors, and administrators whose professional credibility depended on factual accuracy. Would a Babylonian astronomer tracking planetary movements suddenly interrupt his technical calculations to insert random mythology about ancient gods? That would be like finding modern GPS satellite data mixed with Norse legends about Odin. The genres don't naturally blend unless the author sees them as related information. The Sumerians may have been describing reality as they understood it, using their vocabulary and conceptual framework. To them, Anunnaki might have been as specific and factual a term as Assyrian or Akkadian, a designation for a category of beings or a people or a source attribution that we've lost the context to properly translate. The term appears in king lists alongside city names and regnal dates, in temple administrative texts alongside measurements and inventories, in astronomical texts alongside star positions and calculations. It functions grammatically like a proper noun denoting agency, not like a poetic flourish or metaphysical abstraction. So when we examine the 5 cities listed as existing before the flood, we should ask, are these mythological placeholders or geographic data recorded in the same matter-of-fact style as the rest of Sumerian administrative literature? The texts themselves suggest the latter. And if these cities were real, which archaeology confirms for most of them, then what was their relationship to the astronomical coordinate system the Sumerians used? Why are they listed in a specific sequence? And what does it mean that their distribution across the landscape shows patterns that suggest coordination rather than random settlement? The answers begin with understanding where these cities were and how they were positioned relative to each other and to the sky above them. 5 cities before the waters rose. The Sumerian king list exists in multiple versions across museum collections. The Weld Blundell Prism at the Ashmolean Museum in Oxford, the Shine Collection manuscript MS-2855, and various fragmentary tablets from Nippur all preserve versions of the same core text with minor variations. But every version agrees on the opening section. Before the great flood swept over the land, kingship descended from heaven to 5 specific cities in a specific order. In Eridu, Alulim became king. He ruled for 28,800 years. Alaujar ruled for 36,000 years. 2 kings, they ruled for 64,800 years. Then Eridu fell, and the kingship was taken to Bad Tabira. The pattern continues through Bad Tabira. 3 kings, 108,000 years. Larak 1 king, 28,800 years. Sippar 1 king, 21,000 years. And Shuruppak 1 king, 18,600 years. Then comes the notation that would become famous. Then the flood swept over. After the flood, the text continues with more recognisable reign lengths: 120 years, 95 years, 140 years, the kind of lifespans that fit human parameters. The enormous antediluvian reign lengths have generated extensive scholarly debate. Some interpret them as institutional rather than individual. Alulim might represent a dynasty or administrative period, not a single ruler. Others propose different calendrical systems. Perhaps the numbers represent months rather than years, or use counting systems we no longer understand. Still, others suggest the numbers are purely symbolic, mythological statements about the antiquity and importance of these cities rather than literal chronology. What's less debated is the geographic reality of the cities themselves. Archaeologists have identified and excavated 4 of the 5 with reasonable certainty. Eridu located at Tel Abu Shahrain in southern Iraq, shows occupation layers extending back to the Ubaid period around 5400 BC, making it potentially the oldest city in southern Mesopotamia. The site contains the ruins of multiple temple structures, each built atop the previous one, creating a sequence of religious architecture spanning millennia. The Sumerians themselves considered Eridu the oldest city, the place where kingship first descended from heaven, the cult centre of Enki, god of wisdom and the subterranean sweet water ocean called the Abzu. Bad Tabira has been identified at Tel al-Medina between Girsu and Larsa. Excavations revealed a major urban centre with temples and administrative buildings dating to the early dynastic period. The city's Sumerian name means fortress of the copper workers, suggesting metallurgical importance. In the god lists, Bad Tabira was associated with Dumuzid, a deity connected to shepherds and vegetation. Sippar, located at Tel Abu Habar near modern Baghdad, was a major religious centre dedicated to Utu, the sun god. The site yielded tens of thousands of cuneiform tablets when excavated in the 19th century, providing extensive information about the city's administrative, legal and religious activities in later Babylonian periods. Sumerian texts consistently identify Sippar as one of the pre-flood cities, though its remains show occupation primarily from the early dynastic period onward. If there was earlier occupation, it may lie beneath later construction or has been eroded by changes in the Euphrates river course. Shuruppak at Tel Farah was extensively excavated in the early 20th century. The site produced a famous archaeological layer of water-laid silt separating earlier occupation levels from later ones, which excavator Eric Schmidt initially interpreted as evidence of Noah's flood, though this interpretation was later questioned. Regardless of the flood layer's significance, Shuruppak was definitely a major early dynastic city. It's also the legendary home of Ziusudra, called Utnapishtim in the Babylonian versions, the flood hero who survived the deluge by building an ark, making Shurupak's placement as the fifth and final antediluvian city particularly significant in the narrative structure. Larak's location remains uncertain. Some scholars propose it was near Isin or possibly at Tel Wilaya, but no definitive archaeological identification exists. The city appears in various god lists associated with Pabosaj, a deity whose functions remain obscure. The absence of certain identification for Larak doesn't invalidate the list. Many ancient cities mentioned in texts haven't been located, their tales either unexcavated, eroded, or buried beneath later settlements. What's striking about these 5 cities is their geographic distribution. They're not clustered together but spread across southern Mesopotamia in a pattern that covers the entire region the Sumerians called Sumer, the alluvial plain between the Persian Gulf, or where the Gulf's shoreline was in antiquity, and the latitude where the Tigris and Euphrates rivers flow. Closest together, Eridu in the far south, near the ancient coastline, Bad Tabira and Larak in the central region, Sippar in the north, Shuruppak in the middle zone. Together, these cities define the geographic extent of what would become Sumerian civilization. This distribution pattern raises an interesting possibility. If you were establishing a network of settlements in an unpopulated region, how would you position them? You'd want coverage of the entire territory. You'd want access to water sources. You'd want spacing that allows agricultural hinterlands around each city without overlap. You'd want positions that facilitate communication and trade between centres. The 5 antediluvian cities conform to exactly this pattern. They're not randomly scattered or huddled together, they're positioned as though someone surveyed the region, identified optimal locations, and established coordinated settlements. Now consider the astronomical dimension. The Sumerians divided the sky into 3 ways or paths: the way of Anu, near the celestial core, the way of Enlil, the northern celestial hemisphere, and the way of E, the southern celestial hemisphere. These divisions are described in the Mull.Apian Astronomical Compendium and referenced throughout Mesopotamian astronomical texts. Each way was associated with specific constellations and stars, which rose and set at predictable times throughout the year. Observers at different latitudes would see different portions of these ways, with stars at certain declinations never rising above the horizon for northern observers, or never visible to southern observers. The 5 antediluvian cities span a north-south range of roughly 4 degrees of latitude in ancient Mesopotamia, approximately from 30.5 N to 33.5. This is not enough variance to dramatically change which stars are visible, but it's sufficient to affect rising and setting positions, culmination times, and angular heights of celestial objects. An astronomer in Eridu would observe the southernmost stars of the Way of E at higher altitudes than an astronomer in Sippar. An observer in Sippar would see northern stars reach higher culminations than an observer in Eridu. If you wanted to map the complete circuit of visible stars and establish precise astronomical observations across different viewing positions, you would need observatories at different latitudes. 5 cities spanning the region would provide exactly that. The temple structures in these cities show consistent patterns of orientation. Eridu's temples face cardinal directions. Nippur's ziggurats and temples, though Nippur itself isn't listed as antediluvian, show alignments to celestial north and to specific stars. Sumerian and later Babylonian temple construction texts frequently specify that buildings must be oriented according to celestial observation. The Gudea cylinders from Lagash, dating to around 2125 BC, describe how Gudea built the temple of Ningirsu according to a divine plan revealed in a dream, which included specific measurements and orientations determined by astronomical observation. This wasn't unique to Gudea. Temple orientation according to celestial positions was standard Mesopotamian practice. If the 5 antediluvian cities were established deliberately as a network, rather than growing organically over time, we'd expect evidence of planning. We'd expect similar architectural principles, standardized measurements, and coordinated functions. The archaeological record is fragmentary. Most of the oldest occupation layers are buried beneath millennia of later construction or have eroded away. But what survives shows tantalizing hints of standardization. Sumerian temples follow consistent architectural principles across cities. The tripartite temple plan, a central rectangular room with smaller rooms on either side, appears at multiple sites. The ziggurat form, though more prominent in later periods, has precursors in the temple platforms of Eridu and Uruk. The use of standardized bricks with specific ratios, length, width, height proportions, is documented in Sumerian construction from the earliest levels. The measurement systems themselves, the Ninden, about 6, the Iku, about 3,600 square metre, and smaller units based on the cubit, show remarkable consistency across Sumerian cities and through time, suggesting these weren't units that evolved gradually, but standards that were established and maintained. The Nippur tablet, known as the Map of Nippur, dating to around 1500 BC, but likely copying earlier versions, shows a bird's-eye plan of the city with temples, walls, gates, and the Euphrates River labelled. The map is drawn to scale and oriented. Its existence demonstrates that Sumerian urban planning was sophisticated enough to conceptualize cities from an overhead perspective and translate that perspective into graphic representation. If Nippur could be mapped this way, the other major cities presumably could be as well. Did maps of the 5 antediluvian cities exist? If so, did they survive the flood, or were they reconstructed afterward from memory and physical remains? The texts suggest the latter. Multiple Sumerian compositions describe knowledge being preserved through the flood. The Eridu Genesis, the fragmentary creation and flood myth preserved on tablet CBS 1673 from the University of Pennsylvania Museum, describes Ziusudra receiving warning from Enki to build a boat. After the flood subsides, Ziusudra offers sacrifice and the tablet breaks off. In the parallel Akkadian Atrahasis epic, the hero is instructed to preserve the seed of all living things, and after the flood, civilization is restored. The Epic of Gilgamesh describes Utnapishtim, the Akkadian name for the flood hero, living in a distant land after the flood, immortal, possessing knowledge from before the catastrophe. These narratives all include a common element: someone survives, and through that survival, knowledge from before the flood is carried forward. The Sumerian king list states this explicitly. The flood swept over. After the flood had swept over, when kingship was lowered from heaven, kingship was in Kish. Kingship doesn't originate anew, it's lowered again. The same verb used for the pre-flood period. The institution continues, implying cultural continuity despite physical catastrophe. If the 5 antediluvian cities represented a coordinated network, and if that network was associated with astronomical observation and celestial mapping, then the star catalogues and astronomical tablets preserved in later Sumerian and Babylonian temples might be copies of pre-flood observations. The tablets themselves are dated to the 2nd and 1st millennia BC, but cuneiform texts were routinely copied from earlier versions, often with colophons noting they were copies of ancient tablets. The Mol.Aping compendium is typically dated to around 1000 BC, but scholars recognise it incorporates much earlier material, possibly extending back to the late 3rd millennium or earlier. How much earlier? The texts themselves claim the knowledge is ancient, inherited, received from the gods or the antediluvian sages. This creates a methodological challenge for archaeology. We date the physical tablets we possess, but we can't date the information they contain without independent verification. If a tablet from 1000 BC records astronomical observations, we can check those observations against astronomical software to determine what era of the sky they describe. Some researchers have done exactly this. The star positions and rising times in certain sections of Mol.Aping and other astronomical texts correspond to sky positions from the late 3rd millennium BC, not from the dates when the tablets were written. This suggests the tablets were copying earlier observations, but how much earlier? The 5 antediluvian cities provide anchor points for thinking about this question. If these cities actually existed before a major flood event, and the Sumerian king list insists they did, while archaeological stratigraphy at Shuruppak and other sites shows flood deposits, then astronomical observations made from those cities would necessarily predate the flood. If the observations were important enough to preserve, they would be copied onto new tablets after the flood, using whatever materials and technologies were available to the survivors and their descendants. From this perspective, the Sumerian astronomical texts aren't primarily religious documents, they're archives, technical manuals preserving data collected over extensive periods from multiple observation points across southern Mesopotamia. The references to gods aren't theological statements, but attributions. This knowledge came from or through Anu, Enlil, the beings, the Sumerians, called Anunnaki. Whether those attributions are literally accurate, culturally mythologized, or represent something we've lost the context to properly interpret is a separate question from whether the cities were real and the observations were made. The cities were real. The observations were accurate. The network pattern in their distribution is suggestive. What remains is to examine the astronomical system itself in detail to understand how the Sumerians mapped the sky, why that mapping required the precision it demonstrates, and what that precision implies about who taught them to observe the heavens with such care. The sky divided into sections. Tablet BM 86378 in the British Museum is one of the best preserved copies of the Mul.Apin Astronomical Compendium. The text, written in cuneiform on both sides of two tablets, was copied during the Neo-Assyrian period around the 7th century BC, but the astronomical data it contains predates the tablet itself by centuries, possibly over a millennium. Mul.Apin, named after its opening words Mul.Apin, meaning the plough star or constellation Triangulum, is the most comprehensive Babylonian astronomical text, covering star catalogues, planetary observations, seasonal markers, lunar calculations, and the structure of the celestial sphere. The text begins with a systematic catalogue of stars and constellations, organised by their positions in the three ways: the path of Enlil in the northern sky, the path of Anu along the celestial equator, and the path of Ea in the southern sky. Each way contains specific stars and constellations listed in the order they rise throughout the year. The path of Enlil includes 33 stars and constellations visible in the northern celestial hemisphere. The path of Anu contains 23 stars and constellations near the equatorial region. The path of Ea lists 15 stars and constellations in the southern sky. Together, these paths encompass the observable celestial sphere as seen from Mesopotamian latitudes. This tripartite division isn't arbitrary. It reflects the physical geometry of celestial observation from mid-northern latitudes. Stars near the celestial North Pole circle the pole without setting. These are the circumpolar stars, always visible through the night. Stars along the celestial equator rise due east, arc across the southern sky, and set due west, visible for roughly 12 hours. Stars in the southern celestial hemisphere rise in the southeast, trace low arcs across the southern horizon, and set in the southwest, with the southernmost stars barely clearing the horizon or remaining completely invisible from northern latitudes. By dividing the sky into northern, equatorial, and southern zones, Babylonian astronomers created a systematic framework for organising stellar observations and predicting seasonal phenomena. What makes this remarkable is that the threefold division requires understanding that the celestial sphere is a geometric construct, not a literal dome. To conceptualize northern and southern paths separated by an equatorial band, you must recognize that the sky's apparent motion results from Earth's rotation, that the celestial equator is a projection of Earth's equator onto the sky, and that an observer's latitude determines which stars are visible. These are sophisticated astronomical concepts. The Greeks typically receive credit for developing mathematical astronomy and understanding celestial geometry, with Hipparchus creating the first comprehensive star catalogue around 130 BC. Yet Mul.Apin predates Hipparchus by 7 centuries or more, and the astronomical knowledge it contains is even older. The text doesn't merely list stars, it provides functional information for astronomical observation and calendrical calculation. For each star or constellation, Mul.Apin typically notes when it rises heliacally, first visible rising before sunrise, its position relative to other stars, and sometimes its function as a seasonal marker. For example, on the 15th day of month C, the constellation Mul.Apin the Plough rises heliacally. This means that around the 15th day of the 12th Babylonian month, the constellation we call Triangulum first becomes visible in the pre-dawn sky. This observation serves as a calendrical anchor, helping synchronize the lunar calendar with the solar year, a persistent challenge for ancient astronomers since 12 lunar months, about 354 days, fall short of a solar year, about 365.25 days. By tracking heliacal risings of specific stars, Babylonian astronomers could predict when to intercalate an extra month, keeping their lunar calendar aligned with the seasons. This wasn't theoretical knowledge, it had practical agricultural and administrative importance. Planting dates, festival schedules, tax collection periods, and labour obligations all depended on accurate calendrical reckoning. The Mul.Apin system provided that accuracy through systematic celestial observation. But the text contains something more subtle that reveals the depth of Mesopotamian astronomical knowledge. It records the interval between the heliacal rising of one star and the next, measured in days. These intervals allow astronomers to track the apparent motion of the Sun through the stars over the course of the year, effectively mapping the ecliptic, the Sun's path, across the celestial sphere. Modern astronomy knows the ecliptic passes through 12 constellations, completing one circuit in a year. Mul.Apin doesn't use the 12-fold zodiacal division. That development comes later in Babylonian astronomy, first appearing in texts from the late 5th century BC. Instead, it uses the rising intervals of specific stars to mark the Sun's annual progress. This is methodologically more complex than simply dividing the ecliptic into 12 equal sections. It requires multi-year observations to establish precise rising intervals, correcting for leap months and intercalation cycles. It requires understanding that the Sun's position relative to the stars changes systematically throughout the year. It requires mathematical calculation to predict future rising dates based on observed patterns. The Mul.Apin compendium represents the accumulated results of extensive observational astronomy conducted over long periods from fixed locations where sky conditions, horizon features, and observation protocols were standardized. The text also includes instructions for constructing and using a sundial, descriptions of the water clock, methods for determining cardinal directions from shadow lengths, and calculations for the length of daylight and darkness throughout the year at different seasons. These aren't mystical or religious procedures, they're technical instructions for astronomical instruments and mathematical procedures. The tone is instructional, assuming the reader is a trained astronomer who needs precise data for observational work. This brings us to a critical question. Where were these observations made? The Mul.Apin text doesn't specify. It simply presents the data as established knowledge. But astronomical observations are location dependent. The heliacal rising of a star occurs when it first becomes visible on the eastern horizon just before sunrise. That moment depends on the observer's latitude, the local horizon profile or flecturo, atmospheric conditions, and the star's position on the celestial sphere. An observation from Babylon at 32.5 N wouldn't match an observation from Nineveh at 36.3 N. If Babylonian astronomers were copying observations made elsewhere, we'd expect small discrepancies, but if they recalibrated the data for their own location, they'd need to understand how latitude affects rising positions, which implies geometric understanding of the celestial sphere. Some researchers have attempted to determine the original observational latitude of Mul.Apin data by comparing the listed stars with modern calculations of visibility at ancient dates from various latitudes. The results suggest the observations fit best with latitudes in southern Mesopotamia, roughly 31-33 N, exactly the range spanning the 5 antediluvian cities. This doesn't prove the observations originated from those cities, but it's consistent with that hypothesis. If astronomers at Eridu, Bad Tabira, Larak, Sippar and Shuruppak were systematically observing the sky and recording their observations, those records compiled together would create a comprehensive dataset covering the entire observable sky from slightly different perspectives, which when combined would produce a more complete and accurate celestial map than any single observing location could provide. This is exactly how modern astronomy worked before satellite observations. Multiple observatories at different latitudes contributed data to create comprehensive star catalogues. The Carte du Ciel project in the late 19th century involved observatories across the globe photographing the entire sky in a coordinated effort. Ancient Mesopotamian astronomy may have operated similarly, not out of modern scientific methodology, but out of practical necessity. If your civilization consists of multiple urban centres, each with temple observatories, Pooling astronomical data from all centres improves accuracy and completeness. The tablets themselves provide hints of this collaborative approach. The Mole.Aping compendium exists in multiple copies found at different sites: Nineveh, Babylon, Ashur, Uruk. Each copy is essentially identical, suggesting they derive from a common master text that was distributed and recopied across the region. This implies institutional continuity and standardization. Someone established authoritative versions of astronomical texts, and scribes at various cities copied those versions faithfully, preserving not just the content, but the format and organization. This level of standardization requires centralized authority or shared protocols, precisely what we'd expect if the astronomical system originated from a coordinated network rather than developing independently in each city. The organization of the star lists themselves reinforces this impression. The stars are grouped not alphabetically or randomly, but by their positions in the three ways, which are subdivided into rising intervals. This is a coordinate system, a framework for uniquely identifying any star's position by specifying which way it belongs to and where in the sequence of risings it appears. An astronomer in any Mesopotamian city could use this system to communicate observations with astronomers elsewhere. The star X in the path of Enlil rose 10 days after the star Y in the path of Anu is a precise positional description that works regardless of local horizon features or specific observing location, as long as both astronomers share the same coordinate framework. Compare this to how modern astronomy uses right ascension and declination as celestial coordinates. Right ascension measures position along the celestial equator to longitude on Earth, while declination measures angular distance north or south of the celestial equator to decollate. These coordinates allow astronomers anywhere on Earth to specify a star's position unambiguously. The Babylonian system isn't mathematically identical, but it serves the same function, providing a standardized framework for describing stellar positions that multiple observers can use and understand. The three ways also have symbolic associations that some scholars interpret as purely mythological. The path of Enlil is the realm of Enlil, chief god of the Sumerian pantheon, associated with wind, storms, and kingship. The path of Anu belongs to Anu, the sky god, father of the gods, representing heaven itself. The path of Ea corresponds to Ea, god of water, wisdom, and the subterranean Abzu. On one level, these associations are clearly religious. Assigning deities to celestial regions is common in ancient cosmologies. But on another level, the associations are functional. Enlil's northern realm contains the circumpolar stars that never set, eternally visible, like a king's eternal rule. Anu's equatorial realm contains stars that rise and set predictably, maintaining order, like heaven's established laws. E's southern realm contains stars partially hidden below the horizon, mysterious and deep, like the subterranean waters Ea rules. The symbolic and functional meanings aren't contradictory, they're complementary. Ancient astronomers weren't forced to choose between religious and scientific understanding. The sky was both divine and measurable, sacred and calculable. The Sumerians could believe the stars were divine or divinely ordained, while simultaneously mapping them with mathematical precision. But the precision came first, and the mythology mapped onto it. The three ways exist because celestial geometry creates those divisions at mid-northern latitudes. The assignment of gods to those ways occurred after the divisions were already established as an observational framework. This sequence matters. If religion drove the astronomy, we'd expect symbolic divisions that don't correspond to geometric reality, perhaps 4 quarters matching cardinal directions, or 7 regions matching the 7 classical planets, or 12 sections matching the months. Instead, we get 3 divisions corresponding precisely to observational astronomy's natural categories: circumpolar, equatorial, and southern celestial regions. The system is astronomically rational, then mythologically interpreted. This suggests the astronomical framework preceded its religious elaboration, which implies the astronomy came from somewhere or someone whose primary concern was accurate observation, not symbolic construction. The Mole.18 text includes one more detail worth noting. It assumes the reader has access to observational tools and standardized procedures. Instructions for water clocks and sundials imply these instruments existed and were used. References to horizon markers and cardinal orientation assume observers have fixed observation locations with known horizon features. The precision of the rising intervals implies multi-year data collection. All of this requires institutional support, observatories attached to temples or palaces, trained scribes to record observations, archives to preserve data, and continuity of practice across generations. Sumerian temples were exactly such institutions. They were economic powerhouses, owning vast agricultural lands, employing specialists in various crafts, maintaining archives of administrative and religious texts, and supporting scribes, priests, and scholars. Temple observatory platforms, ziggurats in later periods, provided elevation for celestial observation. The flat roofs of temple buildings served as observation decks. The religious function of temples and their astronomical function weren't separate activities, they were integrated. Festival dates were determined by astronomical observation. Offerings and rituals followed lunar and solar cycles. The gods themselves were associated with celestial bodies, Nana with the moon, Utu with the sun, Inanna with Venus, Ninurta with Saturn. So when the texts say that Enlil established the path of Enlil, or that Anu determined the structure of heaven, or that Ea measured the depths, these statements can be understood in multiple ways. On a mythological level, they're creation accounts. On a practical level, they're attributions. This astronomical knowledge came from or through these sources. On a historical level, they might preserve cultural memory that the coordinate system was taught or transmitted rather than independently discovered, received from the Anunnaki or the antediluvian sages, rather than invented by post-flood Sumerians. The tablets themselves can't tell us which interpretation is correct. What they demonstrate unambiguously is that Mesopotamian astronomy was sophisticated, systematic, and ancient. The knowledge encoded in Mole.18 wasn't gathered in a generation or a century. It represents centuries or millennia of accumulated observation. If the system originated in the 5 antediluvian cities, as the text's own framing suggests, then we're looking at astronomical knowledge that predates the flood event the Sumerians considered a civilizational boundary. After the flood, that knowledge was preserved, continued, and expanded in the post-flood cities, but its foundation was laid before. And if astronomers in multiple cities were systematically mapping the sky using a shared coordinate framework, they weren't just observing, they were surveying. Not surveying the land, but surveying the heavens. Which raises the question, why would you survey the sky unless you intended to use celestial positions to map something else? The answer might lie in the one Sumerian document that explicitly combines astronomy and geography in a single representation, a map that shows not just cities, but the world itself as the Sumerians understood it. Maps that shouldn't exist. Tablet BM 92687 measures roughly 12 centimetres by 8 centimetres, an unassuming clay rectangle housed in the British Museum's Mesopotamian collection. Its significance far exceeds its size. The Babylonian map of the world, also called the Imago Mundi, is the oldest surviving map depicting the world as a geographic whole. Dated to the 6th century BC, it presents a schematic view of the known world, a circular disc representing the Earth, surrounded by a ring labelled Maratu, Bitter River or Salt Sea, the cosmic ocean encircling all land. Within the disc, Babylon is marked at the centre, the Euphrates River flows vertically through the middle, and regions like Assyria, Urartu, and Elam are indicated around Babylon's periphery. But the map doesn't stop at the known world. Beyond the Bitter River, arranged around the outer edge of the circular cosmic ocean, are triangular regions labelled distant regions or regions beyond. The cuneiform text on the reverse of the tablet describes these remote places in mythological terms: lands where the sun is never seen, lands of eternal darkness, lands inhabited by strange creatures. Conventional interpretation treats these as purely mythological additions, the ancient equivalent of here be dragons on medieval maps, filling unknown spaces with imagination rather than information. Yet even the mythological elements contain curiously specific details. One outer region is described in terms of measured distance, at a distance of 7 leagues. Another notes geographical features, mountains, marshes. The text isn't purely fantastical, it intermixes imaginative descriptions with quantifiable information, the same blending of mythology and precise data seen throughout Mesopotamian texts. Why would a cartographer bother specifying distances to imaginary places? Medieval mapmakers didn't note that dragons lived 500 miles west of Iceland. The mythological decorations on medieval maps weren't given geographic coordinates. They were illustrations, not data. The Babylonian map structure suggests it's copying an older conceptual model. The circular earth surrounded by water is a cosmological framework found throughout Mesopotamian literature. The Enuma Elish creation epic describes Tiamat, the salt water, and Apsu, the fresh water, mingling together before the gods separated them and created the ordered world. The circular map reflects this cosmology, the land emerging from and surrounded by water. But cosmology isn't cartography. A religious belief that the world is encircled by ocean doesn't automatically generate a map unless someone attempts to represent that belief geographically. The map's most intriguing feature is what it implies about geographic knowledge. To create even a schematic map of Mesopotamia and surrounding regions, the cartographer needed information about relative positions, distances, and the course of major rivers. The Euphrates flows roughly northwest to southeast through modern Iraq. The map represents this accurately, running north-south through the centre of the disk. Babylon's position on the Euphrates in central Mesopotamia is correct. The placement of Assyria to the north, Elam to the east, and the mountainous regions, likely the Zagros mountain to the northeast, matches geographic reality. This isn't an imaginary fantasy map, it's a simplified but recognisable representation of real geography. The question is, how was this information compiled? By the 6th century BC, the Neo-Babylonian Empire controlled much of Mesopotamia, and officials travelling through the empire could gather geographic information. But creating a map requires more than visiting places. It requires knowing how those places relate spatially to each other. Without aerial perspective, how do you determine that Babylon is roughly 300 kilometres from the Persian Gulf? How do you know that Assyria lies approximately north of Babylon if you're travelling overland through winding river valleys? Geographic mapping at this scale requires either extensive travel with systematic distance recording and directional tracking, difficult without compol, or some method of determining position using fixed references, essentially the ancient equivalent of triangulation. Celestial navigation provides such a method. By observing the altitude of the pole star or the culmination height of other circumpolar stars, ancient navigators could determine latitude, their north-south position. The Babylonians didn't have sextants or precise angle measuring instruments, but the shadow length techniques described in Mull. Appin and other astronomical texts could approximate latitude if applied carefully. An observer in Babylon measuring the noon shadow of a gnomon on the summer solstice would get a different result than an observer in Nineveh making the same measurement on the same day, because the two cities lie at different latitudes, about 32.5 N for Babylon, 36.3 N for Nineveh. If both observers recorded their measurements and compared them, they could calculate the latitudinal distance between the cities. Determining longitude, east-west position, is more difficult without accurate timekeeping. Ancient Mesopotamians lacked mechanical clocks, relying on water clocks and sundials, which aren't precise enough for longitude determination. By comparing local solar noon with a reference meridian, the method used by European navigators in later centuries after the invention of the marine chronometer. But crude estimates of relative longitude could be obtained through travel time and direction, combined with latitudinal fixes from shadow measurements. If Mesopotamian temple observatories at different cities were systematically recording astronomical observations, shadow lengths, star altitudes, heliacal rising dates, and sharing that information, they would accumulate data allowing rough triangulation of city positions. This is essentially what the mole.apin system facilitates: standardized observations from multiple locations using shared protocols, generating a dataset that encodes spatial relationships even if the observers didn't explicitly conceptualize it as cartographic surveying. The 5 antediluvian cities, if they were indeed coordinated settlements established deliberately, would be ideal anchor points for such a system. Their spread across southern Mesopotamia would provide sufficient baseline for determining relative positions. Astronomical observations from each city, compared and compiled, would create a reference framework. Later cities built in the region could be positioned relative to the established reference points, and gradually a map could emerge, not from a single cartographic project, but from centuries of accumulated astronomical and geographic observations conducted by temple scribes as part of their regular duties. This reconstruction is speculative, but it's consistent with the evidence. Mesopotamian astronomy was precise and standardized. Mesopotamian cities maintained archives and shared texts, and Mesopotamian culture produced a world map that, despite its schematic style, accurately represents the relative positions of major geographic features. The cognitive leap required to create such a map, conceptualizing the land from an overhead perspective, understanding spatial relationships between widely separated locations, is the same cognitive leap required for systematic astronomy. Both involve abstracting from direct sensory experience to create geometric models of spatial relationships. The texts themselves hint at this connection. References to the 4 corners of the earth, or the 4 regions, appear frequently in Mesopotamian royal inscriptions, where kings boast of ruling or conquering all 4 quarters. This is typically interpreted as rhetorical flourish, claiming universal dominion through formulaic language. But the phrase might also reflect actual cartographic concepts. A circular map has no corners, but if you overlay cardinal directions, north, south, east, west, onto a circular map, you create 4 quadrants or regions. The 4 corners could be directional quarters, not literal corners, representing a systematic division of geographic space analogous to the 3 ways dividing celestial space. Sumerian texts also frequently reference ME, a concept notoriously difficult to translate, but generally understood as divine decrees or fundamental principles governing reality. The ME are often listed in catalogues: me of kingship, me of priestly office, me of metalworking, me of writing, me of warfare, and so on. Importantly, cities and temples are said to possess me, and losing the me meant losing power and legitimacy. Inanna, in the myth Inanna and Enki, travels to Eridu and tricks Enki into giving her the me, which she brings back to Uruk, transferring power between cities. What if some of the me were actually technical knowledge systems, encoded in tablets and preserved in temple archives? What if the astronomical me included the star catalogues and observational protocols that allowed mapping both sky and land. What if the geographic me included surveys and distance measurements that recorded spatial relationships? In this reading, the Sumerian concept of me isn't purely metaphysical, it's institutional knowledge, the accumulated techniques and data that enable a civilization to function. Losing the me isn't just symbolic defeat, it's literally losing the archives, the technical manuals, the reference standards that make complex activities possible. When the flood swept over the 5 antediluvian cities, destroying buildings and drowning populations, some me could be physically lost, tablets shattered, observatories submerged, measurement standards destroyed. But if some survived, carried to higher ground, preserved in archives on elevated ground, or memorized and reconstructed afterward, then civilization could rebuild using the surviving me as templates. This is essentially what the Sumerian king list describes: kingship and its associated knowledge descending from heaven, being established in cities, then the flood interrupting but not ending the chain, with kingship descending again afterward to new cities. The Babylonian map of the world, created in the 6th century BC, might be a simplified version of geographic knowledge far older. The symbolic circular form, the cosmic ocean boundary, these elements could be ancient Near Eastern cosmological conventions imposed on real geographic data. If so, the schematic nature of the map doesn't reflect lack of detailed knowledge, but rather a stylistic choice to represent complex geography in simplified form, much as modern subway maps simplify city layouts to show only the information travellers need. The outer regions beyond the Bitter River are the most mysterious aspect of the map. Mainstream interpretation dismisses them as fantasy. But what if they represent garbled information about distant places, transmitted through trade routes or second-hand accounts? Ancient Mesopotamia had trade connections extending to the Indus Valley, Anatolia, Egypt, and the Arabian Peninsula. Goods like lapis lazuli from Afghanistan and copper from Oman passed through Mesopotamian trading networks. Along with goods came information, descriptions of distant lands, their geography, their resources, their peculiarities. Some of this information would be accurate, some exaggerated, some misunderstood. When recorded by scribes who'd never visited these distant places, the descriptions might blend reality and imagination in ways indistinguishable to modern readers. One outer region on the map is associated with the sunrise, the place where the sun emerges. Another is where the sun cannot be seen. These might be mythological statements about the daily solar cycle, the sun rising in the east and setting in the west, with references to lands beyond the known world in those cardinal directions. Or they might be distorted memories of information about extreme latitudes, the Arctic regions where the sun doesn't rise in winter or doesn't set in summer, phenomena that would seem mythological to Mesopotamians living at 32n latitude, but are literal reality at high latitudes. If the Anunnaki or the antediluvian sages possessed geographic knowledge extending beyond Mesopotamia, that knowledge would have been transmitted in some form, perhaps as maps, perhaps as tablets describing distant lands. After the flood, if such information survived, it might be copied and preserved, but gradually transformed through repeated copying and cultural reinterpretation. Specific data points could become mythologized if the copiers no longer understood their original context. A reference to the land where the sun circles the horizon might be an accurate description of polar phenomena, but to a Mesopotamian scribe unfamiliar with Arctic conditions, it would sound mythological, perhaps prompting elaboration with imaginative details. This is speculation, but it illustrates the interpretive challenge. We can dismiss ancient texts as mythology when they describe things beyond our expectation of what the ancients could know, or we can ask whether some mythological elements might encode distorted memories of actual information. The Babylonian map is real and shows real geographic knowledge, Its mythological outer regions might be purely imaginative, or they might be the degraded remnants of once accurate information about distant places, transmitted through multiple layers of copying and cultural transformation until the factual core is nearly unrecognizable beneath mythological. Elaboration. What's undeniable is that Mesopotamian civilization possessed cartographic concepts and astronomical knowledge sophisticated enough to create such a map. They understood the world as a geographic whole that could be represented schematically. They positioned cities within that framework based on real spatial relationships. And they framed this knowledge within cosmological beliefs about the structure of reality, the Earth as a disk, the cosmic ocean encircling it, the heavens above, the Abzu below. To create such frameworks requires measurement. And measurement, conducted systematically across multiple locations, requires standards, protocols, and institutions to maintain them. The Sumerian temples were exactly such institutions. The question is whether those institutions invented the knowledge systems they maintained, or inherited them from predecessors whose achievements the flood nearly erased, but couldn't entirely destroy. The answer might lie in examining the temples themselves, their architecture, their orientations, and the precision of their construction. The gods who measured the earth. In 2125 BC, Gudea, governor of the Sumerian city-state of Lagash, undertook the reconstruction of the Enunu, the temple of the god Ningirsu. The project is extensively documented on two large clay cylinders, now in the Louvre Museum, inscribed with Sumerian text describing every phase of the temple's construction. What makes these Gudea cylinders remarkable isn't just their detailed account of Bronze Age engineering, but the specificity with which the text describes the origin of the temple's design. According to the inscription, Ningirsu appeared to Gudea in a dream, showing him the plan of the temple. The description includes architectural specifications, the temple's orientation, its dimensions, the layout of rooms, the placement of gates, delivered as divine revelation. Gudea consults priests and the goddess Nanshi to interpret the dream's details. He travels to obtain specific materials: cedar from the Amanus Mountains, gold from Meluha, copper from Magan, stones from distant quarries. The construction proceeds according to the divinely revealed plan, with repeated emphasis on exact measurements and proper orientation. Modern readers might interpret this as religious literature sanctifying a building project, attributing the design to divine inspiration to legitimize Gudea's expenditure of resources. But the text's tone isn't metaphorical or poetic. It reads like a construction report that happens to credit divine authorship. The measurements are real, specified in cubits and nindan. The materials are real, coming from identifiable trade sources. The labour force is documented. The only unusual element is that the architect is a god appearing in a dream rather than a human engineer. What if we take the text seriously on its own terms without dismissing it as religious fiction? Not necessarily accepting that Ningirsu literally appeared in a dream, but accepting that Gudea sincerely believed he was rebuilding the temple according to a sacred plan that had divine origin, a plan preserved in temple archives, perhaps on old tablets, which Gudea interpreted through the religious lens of his culture. The temple wasn't a new invention, but a restoration of something ancient, built according to specifications maintained by the priesthood, who framed those specifications in terms of divine revelation, because that's how their culture understood the authority of inherited knowledge. Temple archives throughout Mesopotamia contain technical texts, mathematical problems, geometric calculations, measurement standards, architectural plans. Some of these texts are explicitly instructional. If a temple has a length of X and a width of Y, the volume of bricks required is Z. Others are reference tables, ratios, conversion factors, standard dimensions for various architectural elements. These weren't religious texts, but engineering manuals, maintained by temple scribes because temples were the primary institutions sponsoring large-scale construction, and institutional knowledge had to be preserved across generations. The Sumerian measurement system itself shows remarkable standardization. The basic unit of length was the cubit, approximately 50 centimeters, divided into smaller units, the palm and the finger. Larger units included the nindan 12 cubits, about 6 meter, and the distance measures used for land surveying. Area was measured in aiku, approximately 3,600 square meter, and bur, larger agricultural plots. Volume measurements existed for grain and liquids. These weren't arbitrary, they were standardized across Sumerian city-states and maintained over centuries. A cubit in Lagash was the same as a cubit in Ur, which was the same as a cubit in Nippur. How does a civilization establish such standardization? In modern times, we have international bureaus maintaining physical standards, the platinum iridium meter bar, the atomic clock definition of the second. Ancient civilizations needed analogous systems. Someone had to create master standards, distribute copies to various cities, and ensure those copies remained accurate through regular comparison and recalibration. In Mesopotamia, temples served this function. The Temple of Enlil in Nippur held particular importance. Nippur was never a political capital, but remained the religious centre of Sumer throughout its history, the one city all Sumerian city-states recognised as sacred neutral ground. Nippur's temple likely maintained master standards that other cities referenced. This is documented in the archaeological record. Excavations at Nippur uncovered precisely cut stone objects with standardized dimensions, interpreted as measurement standards. Clay tablets from temple archives record the dimensions of the temple itself and the city's sacred precincts. One tablet, the map of Nippur dating to around 1500 BC, provides a scaled plan of the city showing walls, gates, the Euphrates River, and temples. The map is oriented and proportional, demonstrating that Sumerian scribes conceptualized cities from an overhead perspective and understood cartographic representation. Temple construction texts frequently specify orientation according to celestial observations. Foundations were laid with corners aligned to cardinal directions, determined by tracking the sun's shadow or observing the rising and setting positions of specific stars. The Babylonian astrolabe texts, which are astronomical compendiums similar to Mul.apin, include instructions for determining true north by observing circumpolar stars. This wasn't symbolic or approximate, it was precise surveying practice. Modern archaeoastronomers, measuring the orientations of Mesopotamian temples, find alignments to cardinal directions accurate to within a degree or two, remarkable precision given the tools available. Why did orientation matter? On a practical level, aligning buildings to cardinal directions provides a consistent reference framework across different structures and cities. If every temple faces east or has its entrance on the south side, then architects and builders across the region work from a shared standard, simplifying construction and ensuring structures conform to expected patterns. On a religious level, cardinal orientation connected earthly temples to cosmic order, the temple as a microcosm of the universe, its structure reflecting celestial patterns. But the practical and religious motivations aren't mutually exclusive, they reinforce each other. Precision in orientation serves functional purposes and simultaneously embodies religious meaning. The ziggurats of later periods, massive stepped pyramid structures supporting temples at their summits, are often interpreted as symbolic mountains, recreating the primordial mound that emerged from the waters of chaos in Mesopotamian creation myths. But ziggurats also function as elevated observation platforms, providing clear sightlines to horizons for astronomical observation. The ziggurat of Ur, the best preserved example, has staircases oriented precisely to cardinal directions. The summit platform would have been ideal for tracking stellar risings and settings, solar observations, and planetary movements. The ziggurat's religious significance as a link between heaven and earth, and its practical function as an observatory, are aspects of the same conceptual framework. Connecting the human realm to cosmic order requires both physical elevation and conceptual understanding of celestial patterns. Eridu, the first of the 5 antediluvian cities, shows a remarkable sequence of temple structures excavated by archaeologists. The lowest levels, dating to the Ubaid period around 5400 BC, contain small shrines built and rebuilt on the same spot over centuries, each new structure built atop the ruins of its predecessor. By the Uruk period around 3500 BC, these shrines had evolved into substantial temple platforms. The continuity of sacred function at the same location across 2,000 years suggests Eridu's significance wasn't arbitrary, but reflected something inherent to the site, its geographic position, its resources, or its role within a larger network of settlements. The temple at Eridu, the Abzu, was dedicated to Enki, the god associated with wisdom, fresh water, and the Abzu, the subterranean ocean of fresh water the Sumerians believed lay beneath the earth. Enki's association with Eridu is consistent across all Sumerian texts. He's the city's founder and patron, the one who established Eridu as the first city where kingship descended from heaven. Enki is also the god most closely associated with the transmission of knowledge. He teaches humanity the arts of civilization, he instructs the Apkallu sages who go forth to other cities, and he warns the Asudra about the impending flood, instructing him to save the seed of all living things. If Eridu was genuinely the first city, its temple the first Iabzu, then the knowledge systems associated with Enki, mathematics, astronomy, construction, surveying, would originate there and spread to other cities. The 5 antediluvian cities aren't described as founded simultaneously, but in sequence. First Eridu, then Bad Tibira, then Larak, Sippar, and Shuruppak. This suggests a process of expansion, with each new city established from the previous one, perhaps carrying knowledge, measurement standards, and protocols from the founding city. In such a scenario, standardization wouldn't be imposed afterward through political unity, it would be built into the system from the beginning. If Eridu's priests established the cubit standard, the astronomical observation protocols, and the temple orientation methods, and if those same priests or their trained successors established Bad Tibira, they would naturally use the same standards in the new city. As each subsequent city was founded, it would inherit the same systems, creating network-wide consistency not through centralized enforcement, but through shared origin. The texts describing the Apkallu, the 7 sages sent by Enki, fit this interpretation. Each Apkallu is associated with a specific city and a specific antediluvian king. They're described as teaching the arts of civilization, architecture, writing, mathematics, priesthood, divination. If we strip away the mythological framing, we're left with the transfer of technical knowledge from a central source, Enki city, to other urban centres, conducted by trained specialists who establish institutions and train local populations in complex technologies. The later Babylonian tradition explicitly states that the Apkallu were beings who emerged from the sea, wore garments like fish, and taught humanity during the day before returning to the water at night. This imagery is bizarre and easily dismissed as mythology, but the description includes oddly specific details. They came from the sea. Eridu was near the ancient coastline of the Persian Gulf, so visitors arriving by sea would literally come from that direction. They wore garments like fish, perhaps protective clothing, or distinctive costumes associated with their role. They taught during the day and left at night. Perhaps they maintained their own separate quarters or returned to ships, keeping social distance from the local population they were instructing. These rationalizations are speculative, but they illustrate that mythological descriptions sometimes contain realistic details that could derive from cultural memories of actual events, later elaborated with imaginative additions. The core claim that technical knowledge was transmitted to Sumerian cities by specialists from a central source is historically plausible. What's mythological is framing those specialists as supernatural beings sent by a god. But if the Sumerians conceptualized Enki as the patron of Eridu and the source of wisdom, then describing knowledge transmission in terms of Enki's agents is culturally logical. They might be describing real historical processes using their culture's interpretive framework. The precision of Mesopotamian temple construction, the standardization of measurements, the continuity of sacred sites, and the text describing knowledge transmission all point toward a sophisticated civilization with institutional mechanisms for preserving and disseminating technical knowledge. That civilization appeared relatively suddenly in the archaeological record, already possessing its key technologies and organizational structures. The Sumerians themselves didn't claim credit for inventing these systems. They attributed them to the gods, to the antediluvian sages, to inherited me that had been passed down. We can interpret this as mythology, which it certainly is in form, or we can interpret it as cultural memory, expressed through mythological language of a civilization that really did inherit significant knowledge from predecessors whose achievements were nearly lost in a catastrophic flood, but survived just enough to allow reconstruction. The physical evidence, the temples, the tablets, the standardized measurements, demonstrates the knowledge existed. The texts explain where the Sumerians believed it came from. Whether those explanations are literally accurate, symbolically encoded history, or pure invention is a question we might not be able to answer definitively. But dismissing them as mere mythology without examining what historical realities they might encode is intellectually premature, especially when we consider that the Sumerians weren't alone in describing pre-flood civilizations taught by divine or semi-divine beings. The pattern appears across multiple cultures that had no apparent contact, which raises the question, is cultural memory of a lost advanced civilization a common mythological trope, or is it a common memory of actual history preserved in the myths of peoples who experienced the same catastrophe from different locations? Enki's civilizing mission. The term Apkallu appears in cuneiform texts spanning over 2,000 years, from early Sumerian compositions to late Babylonian scholarly works. The word is Akkadian, equivalent to Sumerian Abgal, meaning great wise one or sage. The Apkallu are consistently described as 7 primordial sages who lived before the flood, created by the god Akkadian name for Enki to bring civilization to humanity. Each Apkallu served during the reign of one of the antediluvian kings, acting as advisor and instructor to both king and populace. The Berossus tradition, recorded by the Babylonian priest Berossus in the 3rd century BC and preserved in fragments by later Greek writers, provides the most detailed account of the Apkallu under the name Oannes and his successors. According to Berossus, Oannes was a creature who emerged from the sea near Babylon, possessing reason and speech. His body resembled a fish, but beneath a fish's head was a human head, and beneath the fish's tail were human feet. During daylight hours, Oannes taught humans writing, arts, sciences, construction techniques, agricultural practices, and legal principles. At night, he returned to the sea, taking no food. After Oannes came other similar beings, 6 more, each appearing during successive reigns of the antediluvian kings. Berossus's account is late and transmitted through Greek sources, so its details might be corrupted or embellished, but it preserves core elements present in earlier cuneiform texts. The Apkallu were 7, they preceded the flood, they taught civilization, they were associated with water, and each corresponded to a specific time period or king. Sumerian and Akkadian texts don't describe the Apkallu as fish-like creatures, but as sages or priests possessing me, divine wisdom, or specialized knowledge. The fish imagery likely relates to their association with Ea Enki, the god of the Abzu, the subterranean freshwater ocean. E's sacred animal was the fish, and his iconography often included flowing streams. Beings associated with Ea might be depicted with aquatic symbolism without necessarily being literal fishmen. The 7 Apkallu are named in various texts, though spellings and lists vary. The most common names include Adapa, also Uan, Wanduga, Enmeduga, Enmegalama, Enmebuluga, Anenlilda, and Utuabzu. Adapa the first appears in his own literary composition, The Myth of Adapa, where he's described as a priest of Ea in Eridu, granted wisdom by Ea, but denied immortality. When Adapa accidentally breaks the wings of the south wind, he's summoned to heaven to answer for it. Ea advises him not to eat or drink anything offered in heaven, fearing it will be the food of death. In heaven, Anu offers Adapa the food and water of immortality, but Adapa refuses, following Ea's advice. Anu laughs, and Adapa is returned to earth, wise but mortal. The story is often interpreted as explaining why humans are mortal despite possessing wisdom, but it contains interesting details. Adapa is explicitly a human, not a god, yet he has access to divine realms, speaks with Anu, and is powerful enough to break the south wind's wings and act with cosmic consequences. He's described as a priest, a sage, and a fisherman. He possesses wisdom granted directly by Ea. He serves as intermediary between the divine and human realms. This profile, human specialist, possessing extraordinary knowledge granted by a god, serving in a temple, teaching others, fits the general description of the Apkallu. If Adapa represents a historical figure or a historical role, perhaps the title of high priests in Eridu, then the myth of Adapa might encode cultural memory of early Sumerian priesthood and its relationship to knowledge transmission. The detail that Adapa was a fisherman might indicate Eridu's coastal location and reliance on fishing. The association with Ea's temple places him in the institutional centre where knowledge was preserved and taught. The granting of wisdom by Ea could represent intensive training in mathematics, astronomy, writing, and other specialised knowledge maintained by the priesthood. Similarly, the other 6 Apkallu might represent early priestly roles or titles in the antediluvian cities. Each Apkallu associated with a specific king suggests an institutional relationship between secular and religious authority. The king rules the city politically, while the sage advises and maintains the knowledge systems on which the city's functioning depends. This is exactly how Mesopotamian cities operated in later periods. Temples and palaces were separate but interdependent institutions. The king provided military protection and political authority. The temple provided religious legitimacy, education, and technical expertise in areas like astronomy, medicine, and engineering. The texts describing the Apkallu's activities emphasize teaching and establishing order. They're credited with founding cities, building temples, introducing writing, establishing rituals, and teaching all the crafts. This is civilizational package, the suite of technologies and organizational structures that distinguish urban civilization from village agriculture. Archaeologically, this package appears in Sumer around 3200 BC in what's called the Uruk period, named after the city of Uruk, which became the largest urban centre in Mesopotamia during this time. But Uruk isn't listed among the 5 antediluvian cities. The king list places Uruk in the post-flood section, one of the cities to which kingship descended after the deluge. Yet Uruk's archaeological record shows continuous occupation from the Ubaid period through the early dynastic period, including the time when the flood supposedly occurred. This creates a chronological puzzle. If the flood was a literal global or regional deluge that destroyed the antediluvian cities, why does Uruk show uninterrupted occupation? If the flood wasn't literal but symbolic, what does the before and after the flood distinction in the king list actually represent? One possibility is that the flood refers to a specific catastrophic event that affected some cities more than others. Cities in low-lying areas near rivers or coasts would be devastated by severe flooding, while cities on higher ground might survive with less damage. Uruk lies on the Euphrates, but on elevated ground compared to Eridu in the far south. If a major flood event submerged Eridu, Bad Tabira, Larak, Sippar, and Shuruppak, survivors would flee to surviving cities like Uruk, bringing with them the cultural knowledge, including the Apkallu traditions and the astronomical me preserved in temple archives. This scenario fits the textual evidence. The king list doesn't say everyone died in the flood, only that it swept over and kingship afterward descended to new cities. The Eridu Genesis describes Yasudra building an ark and surviving. The Atrahasis epic similarly describes survival and continuation. Cultural continuity through disruption is the consistent theme. Catastrophe interrupts but doesn't end civilization, because knowledge survives through the actions of those who preserve it deliberately. The Apkallu tradition might preserve memory of this knowledge preservation. If the 7 sages were real historical figures, perhaps high priests or specialists in the antediluvian cities, who compiled astronomical observations, measurement standards, architectural plans, and other technical knowledge into tablet archives, and if some of those archives survived the flood or were recreated from memory afterward, then the post-flood cities would inherit genuine antediluvian knowledge. The later Sumerians, knowing this knowledge came from before the flood, would attribute it to the antediluvian sages, who came to be called Apkallu and associated with Ea Enki because Ea was the god of wisdom and the patron of Eridu, the first city. The fish imagery might derive from later iconography elaborating on the connection with Ea and water, or it might encode something more specific. If the Apkallu were associated with sea travel, navigating the Persian Gulf between cities, or travelling along rivers, they might be depicted with aquatic symbolism. Ancient Mesopotamian cylinder seals sometimes show figures with fish-like lower bodies or fish skin cloaks, labelled as Apkallu in accompanying inscriptions. These images are usually interpreted as purely mythological, but they could also be stylized representations of specialists associated with water-based transportation or fisheries, their professional association leading to symbolic representation. Later Mesopotamian tradition distinguished between the 7 antediluvian Apkallu and post-flood sages called Umanu, craftsmen or scholars, who were fully human. The antediluvian Apkallu were considered semi-divine, partaking of both human and divine natures, while post-flood sages were ordinary humans, however learned. This distinction might reflect a cultural understanding that knowledge after the flood was inherited rather than original. The post-flood sages learned from texts and traditions passed down from the antediluvian sages, who had direct contact with the gods or were themselves creations of the gods. If we strip away the mythological framing, this describes exactly what we'd expect in a civilization recovering from catastrophe, survivors and their descendants working from inherited knowledge, teaching new generations based on preserved texts and practices, with cultural memory recognizing that the foundational knowledge came from an earlier, more advanced phase of civilization that the flood nearly destroyed. The Sumerian concept of me, mentioned earlier, is relevant here. The me are divine decrees or principles governing reality, including civilizational technologies. Enki possesses the me in Eridu and in various myths, other gods or cities acquire me from Enki, gaining power and capabilities thereby. The myth Inanna and Enki describes Inanna travelling to Eridu, getting Enki drunk, and receiving the me from him, which she transports to Uruk. The me include kingship, priesthood, writing, metalworking, warfare, music, and dozens of other civilizational elements. After the transfer, Uruk gains preeminence, while Eridu's power wanes. This myth might encode historical memory of knowledge transfer from Eridu, the first city, antediluvian, nearly destroyed to Uruk flood, becoming the new major centre. The me would be the technical knowledge systems, literally the tablets and trained specialists who carried knowledge from the old centre to the new. Inanna getting Enki drunk could be a mythologized version of political negotiation or crisis circumstances, the flood destroying Eridu, survivors taking what knowledge they could to Uruk, re-establishing civilization there. This reading is interpretive and can't be proven, but it offers a coherent explanation for why Sumerian mythology contains so many stories about knowledge transfer, antediluvian sages, floods, and the establishment of post-flood cities. These aren't arbitrary myths, they're structured narratives explaining the origin and transmission of the knowledge systems on which Sumerian civilization depended. The mythological form doesn't negate potential historical content, it reflects how the Sumerians conceptualized and communicated historical memory. The Apkallu tradition spread beyond Mesopotamia. Ancient Israel's tradition of the Nephilim, giants born from the sons of God and the daughters of men, who became the heroes of old, men of renown, might be distantly related. The Book of Enoch, an extra-canonical Jewish text, describes watchers who descended from heaven and taught humans metallurgy, cosmetics, writing, astrology, and other arts, echoing the Apkallu's civilizing mission. Egyptian tradition speaks of the followers of Horus, semi-divine beings who ruled Egypt before the pharaohs and established its civilization. Greek mythology includes the Titan Prometheus, who stole fire from the gods and gave it to humans, teaching them arts and sciences. These parallels don't prove a common historical source. They could represent common mythological archetypes, the culture hero figure who brings civilization to primitive humanity. But the specific details are intriguing. The emphasis on teaching, the pre-flood or primordial time frame, the semi-divine status, the transmission of specific technical knowledge rather than vague wisdom. If multiple cultures independently invented these myths, why do they share such specific elements? If they borrowed from each other, what's the original source? Or if they're all preserving fragmented memories of actual historical knowledge transmission from an earlier civilization, what was that civilization and how did its influence spread so widely? The Sumerian texts themselves provide an answer consistent with the evidence. There was a pre-flood civilization centered in 5 cities, possessing advanced knowledge in astronomy, mathematics, and engineering, which was nearly destroyed by catastrophic flooding, but preserved through deliberate actions of specialists who carried knowledge forward. The specialists became remembered as the Apkallu, semi-divine sages sent by Enki. The knowledge became encoded in temple archives as me, sacred principles maintained by priesthoods. The cities became the 5 antediluvian centres of the king list, where kingship first descended from heaven. Whether this answer is historically accurate, symbolically encoded, or mythologically invented remains debatable, but it's the Sumerians' own explanation, consistently presented across multiple texts and genres. And it leads to one of the most challenging questions. If the antediluvian civilization was so advanced, why did the post-flood Sumerians attribute its knowledge to gods and semi-divine beings? Why not simply say our ancestors were advanced? Perhaps because the technology gap was so large that divine attribution seemed more plausible than human achievement. Or perhaps because Anunnaki, Apkallu, and similar terms didn't mean gods in the sense we understand, but were specific designations for groups or peoples whose identity was clear to the Sumerians but is lost to us. The texts never explain what Anunnaki means because the original audience already knew. We're left guessing. The Anunnaki descent narratives. The term Anunnaki appears hundreds of times throughout Sumerian and Akkadian literature, yet no single text defines it explicitly. The word functions as a proper noun, designating a group of deities or divine beings, sometimes numbered as 7, sometimes as 50, sometimes as an indefinite collective. They're distinguished from other categories of gods, the Igigi, who are often described as lesser gods serving the Anunnaki, and individual named deities like Enlil, Ea, Inanna and Utu, who are Anunnaki, but also possess individual identities and spheres of influence. The etymology of Anunnaki is debated. The most common interpretation derives it from Anunnaki, meaning offspring of Anu, or those of princely/royal blood, with Anu being the sky god and head of the pantheon. This would make the Anunnaki collectively the royal family or court of heaven, the major deities as distinguished from lesser spirits or demons. An alternative reading connects it to Anu-Na, meaning heaven and earth, making the Anunnaki deities of the cosmic order governing both realms. A more literal reading takes it as those who from heaven to earth came, though this interpretation is grammatically controversial and not widely accepted by linguists. What's consistent across texts is functional rather than etymological. The Anunnaki are described as descending from heaven to earth, being assigned to specific locations, establishing order, making decisions about human fate, and governing cosmic and earthly affairs. They're not abstract principles, but agents acting within the world, and their actions are recorded in the same matter-of-fact tone as human political events. The Sumerian composition, The Descent of Inanna, describes Inanna travelling to the underworld, where she encounters 7 judges, the Anunnaki of the underworld, who pass judgment on her. The Babylonian epic of Gilgamesh mentions the Anunnaki carrying torches during the flood, witnessing the destruction. The Atrahasis epic describes the Anunnaki as labouring gods who eventually rebel against their toil, leading to the creation of humans to perform labour instead. The Enuma Elish creation epic describes Marduk slaying Tiamat and creating the world, with the Anunnaki assigned various roles in the newly ordered cosmos. These are diverse contexts: underworld judgment, flood narrative, labour rebellion, creation myth, but the Anunnaki appear in all of them as active participants, not symbolic abstractions. They act, decide, labour, witness. The texts don't explain why they're present or what qualifies them for their roles. Their involvement is simply stated as fact. This suggests the Anunnaki were an understood category within Mesopotamian cosmology, their nature and function sufficiently familiar to the original audience that elaboration wasn't needed. What becomes interesting is the geographic specificity in some texts. The Anunnaki aren't only celestial, they're assigned to cities. Various god lists and temple texts specify which deities preside over which cities: Enlil in Nippur, Enki in Eridu, Nana in Ur, Utu in Sippar, Inanna in Uruk, Ningirsu in Lagash. These assignments aren't arbitrary, they're fundamental to how Sumerian religion operated. Each city had a patron deity who resided in that city's main temple, owned the city's lands, and protected the city's interests. The king of the city was the deity's earthly steward, managing the god's estate on the god's behalf. This system has obvious political utility, it legitimizes kingship and temple authority, but it also reflects a conceptual framework treating the gods as real entities with specific geographic responsibilities. If the Anunnaki are understood as the group of major deities, then the Anunnaki descended to establish cities is equivalent to saying the patron deities were assigned to their respective cities. But the texts often phrase it temporally, not just spatially. The gods descended, then cities were founded, then kingship was established. There's a sequence, arrival, establishment, governance. The Eridu Genesis fragment describes the creation of humans, the founding of 5 cities, and the assignment of kingship to those cities, all orchestrated by the gods Anu, Enlil, Enki, and Ninhursag. The phrasing indicates action: the gods created, the gods founded, the gods established. If this is purely mythological, it's functional myth explaining why cities exist and legitimizing urban civilization. But if it encodes historical memory, it describes colonization, a group arriving, selecting sites, founding settlements, organizing governance. The mythological framing would reflect the Sumerians' understanding that this group, the Anunnaki, had capabilities exceeding ordinary human capacities, either because they were genuinely non-human or because they possessed advanced knowledge that seemed divine to the recipient population. The texts describing the antediluvian period consistently present the cities as having been given their status by divine decree. Eridu didn't become important through conquest or economic dominance. It was established as the first city by Enki. Nippur wasn't politically powerful, but all Sumerian kings sought legitimacy by offering tribute to Nippur's temple, because Enlil, who ruled there, was supreme among the gods. Kingship descended from heaven to specific cities in sequence, not achieved through human ambition. This framing removes agency from humans and attributes civilizational development to divine will. Yet alongside this divine framing, the texts are full of human actions. Kings build temples, wage wars, administer justice, and are held accountable for their successes and failures. The gods don't micromanage, they establish frameworks within which humans act. This parallels how later empires operated. A central authority establishes provinces, assigns governors, and sets policies, but local administrators handle daily governance. If the Anunnaki were not gods in the supernatural sense, but an advanced group establishing a network of settlements, the textual descriptions would be functionally accurate. They arrived, selected sites, founded cities, assigned local rulers, and established governance structures. The problem is, the texts call them gods and attribute supernatural abilities to them, controlling storms, granting immortality, residing in heaven. We can't simply strip away the supernatural elements and keep the geographic and administrative details, treating the texts as misidentified history. That's intellectually dishonest. But we can ask whether the supernatural elements might be later elaborations on actual events whose details were misunderstood or deliberately mythologized by subsequent generations. Consider a hypothetical: an advanced maritime civilization, perhaps from the Persian Gulf or Indian Ocean region, establishes trading posts along the Mesopotamian coast in the 5th or 6th millennium BC. These traders possess navigation skills, astronomical knowledge for seafaring, metallurgy, writing or proto-writing for trade records, and engineering techniques for building permanent structures. They select strategic locations: Eridu near the coast, other sites inland along rivers, and establish settlements that become trading hubs. Local populations interact with these settlers, learning their technologies and organizational methods. Over generations, the settlements grow into cities, the local populations adopt the settlers' technologies, and a hybrid culture emerges, what we call Sumerian civilization. After a major flood disrupts the Gulf Coast, the trading network collapses. The coastal settlements are abandoned or destroyed. The inland cities survive, but lose contact with the original source culture. The inherited technologies, writing, astronomy, mathematics, standardized measurements, are maintained by temple priesthoods, but cultural memory of their origin becomes garbled. A few generations pass. The survivors remember that knowledge came from those who came from the sea or those who came from the sky, if the original group was associated with astronomical navigation, sky and sea might both be used metaphorically. These foreigners are remembered as exceptionally wise, powerful, different from ordinary people. Over more generations, they become mythologized into gods, the Anunnaki, who descended from heaven to establish civilization before the flood. This scenario is speculative and has no direct archaeological support, but it's not impossible. It would explain the sudden appearance of advanced civilization in Sumer, the geographic specificity in the descent narratives, the flood as a boundary event, and the attribution of knowledge to non-human sources. The mythological elaboration would be natural cultural evolution, humans routinely deify ancestors and legendary figures over time. The Sumerians might be doing exactly that. Preserving accurate cultural memory knowledge came from an earlier group who established the first cities in mythological form. That group became the gods Anunnaki. Mainstream archaeology doesn't support this because there's no evidence of a pre-Sumerian advanced maritime civilization in the Persian Gulf. But absence of evidence isn't evidence of absence. The Gulf's sea level rose significantly after the last ice age ended, potentially submerging coastal settlements from earlier periods. Underwater archaeology in the Gulf is limited, and if early settlements existed on the now submerged coastal shelf, they're inaccessible or haven't been searched systematically. The Sumerian flood narratives themselves might preserve memory of this coastal submersion. The Persian Gulf's formation in its current shape occurred during the late prehistoric period as sea levels rose, flooding what had been dry land. Communities living on the coastal plain would have experienced this as catastrophic inundation. The flood remembered in Sumerian texts might not be a single storm event, but the cumulative effects of sea level rise over centuries, compressed in cultural memory into a single dramatic narrative. But this is one speculative interpretation among many. Another interpretation takes the Anunnaki narratives as purely symbolic, representing natural forces personified as deities. Another sees them as political propaganda invented by priestly classes to legitimize their authority by claiming divine sanction. Another views them as psychological archetypes, gods representing aspects of human consciousness or unconscious drives. All of these interpretations have scholarly support, and none can be definitively proven or disproven from the texts alone. What's undeniable is that the Sumerians themselves took the Anunnaki seriously as real entities with whom humans interacted. Temple rituals involved offerings and prayers to the Anunnaki. Kings invoked the Anunnaki as witnesses to treaties and oaths. Legal codes were promulgated in the Anunnaki's names. Astronomical texts referenced the Anunnaki's pathways in the sky. These weren't metaphors or literary devices, they were functional references within a worldview that considered the Anunnaki as real as the Assyrian Empire or the Euphrates River. From the Sumerian perspective, the Anunnaki's involvement in establishing cities and teaching civilization wasn't mythology requiring belief, it was history requiring acknowledgement. Modern scholars categorize these texts as mythology because they involve supernatural beings performing impossible acts, and we exclude supernatural explanations from academic discourse. That methodological decision is reasonable and necessary for scientific rigour, but it creates a hermeneutical gap. We're reading texts that present themselves as describing reality, categorizing them as fiction, and then trying to extract historical information from them while dismissing their own explanatory framework as false. The alternative is to take the texts seriously on their own terms without necessarily accepting their supernatural claims at face value. The Sumerians said the Anunnaki descended to establish cities. We don't have to believe in literal gods descending from heaven, but we can ask, is there historical content encoded in this narrative? The cities were real, the knowledge systems were real, the network pattern was real, the flood disruption was likely real. If the Sumerians attributed these realities to the Anunnaki, maybe the question isn't, were the Anunnaki real? But what were the Anunnaki? What category of beings or people did that term designate in Sumerian understanding, and can we recover that meaning from the textual patterns? The answer might lie in examining not what the texts say, but what they assume, the background information taken for granted, the details that didn't require explanation for the original audience, but are obscure to us. The pre-flood chronologies are one such detail. Pre-flood chronologies and impossible lifespans. The antediluvian section of the Sumerian king list presents a chronological impossibility that scholars have debated for over a century. 8 kings ruling across 5 cities for a combined total of 241,200 years before the flood. These numbers defy any literal interpretation. Alulim of Eridu ruling 28,800 years, En-Megalana of Bad Tabira ruling 43,200 years. Even allowing for ancient exaggeration, the figures are absurd by orders of magnitude. Yet the post-flood section of the same text transitions abruptly to recognisable timescales. The first post-flood king, Gushra of Kish, rules 1200 years, still inflated but approaching plausibility. By the early dynastic period, reign lengths drop to decades, 40 years, 25 years, 36 years, the kind of figures we expect from historical records. The contrast is stark, impossibly long reigns before the flood, gradually normalising reigns afterward. What does this transition represent? One explanation proposes the numbers are symbolic rather than chronological. Mesopotamian numerology attached significance to specific numbers, particularly multiples of 60 in the sexagesimal counting system. Many antediluvian reign lengths are multiples of 3,660, 28,800, 3,600, 36,000, 10, 3,600, 43,200, 12, 3,600. These might represent schematic periods rather than actual years, encoding astronomical cycles or mathematical patterns rather than historical duration. Another explanation suggests different calendrical systems. Perhaps year in the antediluvian section means something different, months, seasons, or abstract time units. If we divide the antediluvian reign lengths by 12, treating them as months rather than years, we get more reasonable figures. 28,800 months equals 2,400 years, 43,200 months equals 3,600 years. Still long, but within range of institutional or dynastic continuity rather than individual lifespans. The kings might represent dynasties or administrative periods rather than individual rulers. A third interpretation focuses on the flood as a chronological reset. The exaggerated antediluvian timescales place that era in a different temporal framework, mythological time, primordial time, time operating under different rules than historical time. The flood marks the transition from mythological to historical chronology. After the flood, time operates as we understand it. Before the flood, different principles applied, not because reality was literally different, but because the antediluvian period existed in cultural memory only, not in documentary records. And memory distorts temporal perception, compressing or expanding durations until they lose realistic scale. What's intriguing is that similar chronological patterns appear in other flood traditions. The biblical Genesis account lists 10 patriarchs from Adam to Noah with lifespans ranging from 365 years to 969 years, followed by a flood, followed by gradually decreasing lifespans until they stabilize around 70-120 years by the time of the Hebrew kingdoms. The structural parallel is exact: inflated pre-flood lifespans, catastrophic flood, normalizing post-flood chronology. The Sumerian king list predates Genesis by well over a millennium, suggesting either cultural borrowing, Hebrew flood traditions, derived from Mesopotamian sources during the Babylonian exile, or independent preservation of a common memory pattern. Egyptian king lists similarly include primordial periods when gods ruled for thousands of years, followed by the followers of Horus for shorter but still extended reigns, followed by historical pharaohs with normal lifespans. Hindu tradition describes yugas, vast cosmic ages lasting hundreds of thousands of years before the current age. Mesoamerican calendars include long count cycles spanning millennia. The pattern of deep antiquity, marked by different temporal scales, followed by transition to historical time, appears across cultures. This could represent common mythological structuring. Humans naturally frame the distant past as qualitatively different from the present, using temporal distortion to signal that difference. Or it could indicate these cultures preserved genuine chronological information about a very ancient past, but lacked frameworks for expressing deep time accurately, resorting to symbolic or inflated numbers to convey antiquity beyond their calendrical system's capacity to measure precisely. Modern archaeology faces a similar challenge with deep prehistory. Radiocarbon dating provides absolute dates, but before writing, we have no king lists, no regnal years, no anchored chronology. We measure in calibrated radiocarbon years before present, a scientific framework unavailable to ancient chroniclers. If the Sumerians knew their civilization's origins stretched back thousands of years beyond their documentary records, how would they express that? They might use symbolic large numbers to indicate very ancient, not intending literal interpretation, but lacking better alternatives. The Sumerian king list's purpose might not be historical chronicle, but legitimation document. By tracing kingship back through the flood to primordial times when gods established cities, the list provides divine pedigree for contemporary kings. The exaggerated chronology serves rhetorical purpose, making the institution of kingship as ancient and sacred as possible. In this reading, the antediluvian section is pure mythology, invented to provide foundation narrative with no historical content. But this interpretation struggles with the geographic specificity. If the antediluvian section is invented, why choose those 5 cities? Why not include Uruk, which became the greatest city? Why include Larak, which was never politically significant? The selection seems based on criteria other than later political importance, perhaps genuine tradition that those 5 cities were oldest, or that they had special religious significance related to the flood narrative, or that they actually did predate other Sumerian cities and the king list. Preserves that chronological priority despite mythologizing the timescales. Archaeological evidence confirms Eridu's extreme antiquity. Pottery sequences and architectural styles document continuous occupation from the Ubaid period, ca 5400 BC, through the Uruk period, ca 3500-3000 BC, and into historical times. If Eridu was genuinely the first Sumerian city founded 2000 years before writing developed, then the king list's placement of Eridu first is historically accurate, even if the chronological specifics are inflated or symbolic. The other 4 cities likewise show early dynastic occupation, and while Larak's location remains uncertain, the other 3 are confirmed archaeological sites from the early urban period. The simplest explanation is that the antediluvian section of the king list preserves genuine historical memory. These 5 cities were the earliest major settlements, but expresses that antiquity through symbolic chronological inflation because the Sumerians lacked precise dating methods for pre-literate periods. The transition to realistic timescales in the post-flood section reflects the transition to documentary records. Once writing developed, reign lengths could be recorded accurately. Before writing, they relied on oral tradition, which distorted chronology beyond recognition over millennia of transmission. This explanation accounts for both the geographic accuracy and the chronological impossibility. The cities were real and really ancient. The timeline is mythologized because it predates record keeping. The flood serves as narrative boundary between pre-documentary tradition and documentary history. What the Sumerians understood as flood might have been the Ubaid-Uruk transition, Raka 4000-3500 BC, When settlement patterns, pottery styles, and social organization changed significantly, a civilizational flood-marking transformation from village culture to urban civilization compressed memory into a single catastrophic event. Or the flood was a literal, catastrophic inundation that disrupted the early cities, forcing reorganization and knowledge preservation that survivors carried forward. The Sumerian texts themselves insist on literal flood, describing boats, survival, and geographic specifics. Dismissing this as pure invention assumes the Sumerians were fundamentally confused about their own history. But if their astronomical knowledge was accurate, their mathematics correct, their measurements standardized, and their geographic data verifiable, perhaps their historical claims deserve more credit than we typically grant. The chronological puzzle doesn't resolve easily, but it points toward a conclusion. The Sumerians believed their civilization extended back thousands of years before the flood, to cities whose foundations were so ancient that memory of their origins had become mythologized. Whether those origins involved the Anunnaki in literal or symbolic sense, the pattern is clear. Civilizational knowledge had deep roots, predating the oldest documentary evidence, preserved through crisis that nearly destroyed it. The crisis itself, the flood event, deserves careful examination, not as mythology, but as the civilizational boundary the Sumerians considered it to be. The flood as boundary event. Every version of the Sumerian flood narrative agrees on core elements. The gods decide to send a flood to destroy humanity. One god, usually Enki-E, warns a human hero, Zisudra Atrahasis Utnapishtim. The hero builds a boat following divine specifications. Flood comes and destroys everything. The boat survives. The hero makes sacrifice, and the gods grant him blessing or immortality. The details vary between versions, but the structure is consistent, and importantly, the flood is presented as a historical event dividing before and after. The Eridu Genesis tablet CBS 1673 from the University of Pennsylvania Museum, though fragmentary, describes the creation of humans, the establishment of 5 cities with their kingship, and the gods' decision to send the flood. The text breaks off during the flood description, but resumes with Ziusudra offering sacrifice after surviving. The Atrahasis epic from the British Museum BM 1889 0426 236 provides more complete narrative. The gods create humans to perform labour, humanity multiplies and becomes noisy, disturbing the gods' rest. Enlil decides to destroy humanity through plague, drought, and finally flood, but Enki warns Atrahasis and provides boat specifications. The Epic of Gilgamesh includes the flood story in Tablet C, where Utnapishtim, the Akkadian name for the flood hero, describes how Ea came to him in a dream, instructing him to abandon possessions and save life by building a boat. The specifications are detailed. The boat should be cubic, 120 cubits on each side, with 6 decks and 7 compartments. Utnapishtim loads his family, craftsmen with their skills, and seed of all living things. The storm lasts 6 days and 7 nights. When it subsides, Utnapishtim releases birds, a dove, a swallow, and finally a raven that doesn't return, indicating dry land. He offers sacrifice, and the gods, smelling the sweet savour, gather around. These aren't vague myths, they're detailed narratives with geographic specifics. The boat lands on Mount Nisir, temporal measurements, 6 days and 7 nights, procedural instructions, dimensions, multiple decks, loading sequence, and consistent plot structure. The Mesopotamian flood narratives clearly derive from common source material, adapted and modified through different literary traditions, but preserving core historical memory. Archaeological evidence for major flooding in Mesopotamia is ambiguous. Excavations at various sites, Shuruppak, Uruk, Kish, have found layers of water-laid silt separating occupation levels, initially interpreted as evidence of the flood. But these flood layers don't correlate chronologically between sites. the flood deposit at dates to different period than the deposit at Shurapak, indicating local flooding events rather than a single universal deluge. This led archaeologists to conclude there was no single great flood matching the biblical Mesopotamian narratives, just ordinary river flooding that the ancients mythologized into cosmic catastrophe. However, this conclusion may be premature. The Persian Gulf shoreline was significantly different in the 6th and 5th millennia BC than today. Sea level rise following the last ice age progressively flooded the Gulf basin, turning what had been dry or marshy lowland into open water. Communities living on the coastal plains would have experienced this as devastating inundation, not sudden like a storm, but relentless, rising water that didn't recede, forcing abandonment of ancestral lands. Over centuries, the Gulf advanced inland, submerging hundreds of square kilometres. From the perspective of multiple generations watching their world drown, this would be apocalyptic, a flood sent by gods to destroy the earth. Eridu's location is significant here. As the southernmost antediluvian city, Eridu sat near the ancient Gulf Coast. If sea level rise submerged the coastal regions where earlier settlements existed, Eridu would be on the boundary, far enough inland to survive initially, but close enough to be directly impacted. The archaeological sequence at Eridu shows continuous occupation through the period when the Gulf was advancing, suggesting the site remained above water while lower lying areas flooded. Survivors from submerged coastal settlements would naturally flee to Eridu, the nearest surviving city, bringing with them cultural memory of the catastrophe. This scenario reconciles the textual and archaeological evidence. There was major flooding, but it was gradual sea level rise rather than single storm event. The compression of centuries-long process into single dramatic narrative is typical of oral tradition. Events that unfolded over generations become mythologized into a shorter time frame. The geographic specifics, 5 cities before the flood, different cities after, reflect the actual abandonment of southern coastal settlements and shift of population centres inland and northward. The flood narrative's emphasis on survival and knowledge preservation takes on particular significance in this context. If the coastal regions held early settlements with advanced knowledge, astronomical observation posts tracking seasonal patterns, workshops teaching metallurgy and craft techniques, temples maintaining measurement standards, then their submersion would represent catastrophic knowledge loss unless deliberately preserved. The image of Ziusudra loading his boat with seed of all living things and craftsmen with their skills is a knowledge preservation mission, saving not just biological diversity but technological capability. The Sumerian texts consistently present post-flood civilization as reconstruction rather than new invention. Kingship descends from heaven again to Kish, not for the first time, but in continuity with antediluvian kingship. The astronomical observations compiled in mold.apin span centuries, implying observational continuity through disruptive events. The measurement standards show no discontinuity. The cubit used in early dynastic temples matches the cubit used in later periods, suggesting the standards were maintained through whatever crisis occurred. This pattern, catastrophic disruption followed by cultural continuity, is exactly what we'd expect if the flood destroyed settlements and populations, but survivors preserved enough knowledge to rebuild. The cities that emerged after the flood used the same technologies, worshipped the same gods, maintained the same institutional structures as the antediluvian cities because they were founded by survivors who deliberately carried forward the old knowledge. The Apkallu tradition of sages teaching civilization fits this pattern, specialists preserving and transmitting technical knowledge through crisis. The flood's role as civilizational boundary extends beyond Mesopotamia. Similar flood traditions appear globally: Noah in Genesis, Manu in Hindu tradition, Deucalion in Greek myth, various flood heroes in Chinese, Mesoamerican, and Native American traditions. The 19th century comparative mythology school interpreted these as evidence of universal flood, attempting to correlate them with geological events. Modern scholars treat them as independent mythological developments, common archetypes reflecting humans' experience with local flooding projected onto cosmic scale. But the specific parallels between Mesopotamian and biblical flood narratives are too close for independent development. Genesis clearly draws on Mesopotamian sources, adapted to monotheistic theology. The question is whether the Mesopotamian source itself was invented mythology or historical memory. The Sumerians were the earliest civilization to write flood narratives, but they might not have invented them. They might have inherited them from predecessors whose catastrophe they remembered. The texts themselves insist on historical reality. The Sumerian king list treats the flood as chronological marker, not mythological preface. Astronomical and administrative texts reference pre-flood knowledge without explanation, assuming readers knew what that meant. Temple archives contain copies of ancient tablets, with colophons noting they reproduced antediluvian originals. The Sumerians didn't treat the flood as metaphor, they treated it as history, a boundary event dividing civilization's timeline into before and after. We can reject their interpretation, categorizing it as mythology despite their insistence otherwise. Or we can accept that they knew their own history better than we do, that their categorization of events as historical should be respected, and that the flood narratives preserve memory of real catastrophe, probably sea level rise in the Persian Gulf, that disrupted early civilization severely, enough to become the defining historical boundary, the event against which all chronology was measured. If the 5 antediluvian cities existed before this catastrophe, and if they represented a coordinated network using astronomical observation and standardized measurements, then the flood's destruction would explain why Sumerian civilization appears to start suddenly in the archaeological record. It didn't start suddenly, it restarted, rebuilding from surviving knowledge after catastrophic disruption. The apparent suddenness is the recovery phase, when survivors re-establish cities using preserved technologies, creating archaeological visibility where previous settlements had been submerged or abandoned. The astronomical tablets, the city maps, the measurement standards, the Apkallu traditions all point toward knowledge continuity through disruption. The flood wasn't end, but interruption. And on the far side of that interruption, the knowledge survived, maintained by those who understood its importance and took deliberate action to preserve it against catastrophe. The Sumerians remembered this, they recorded it, and they built their civilization on the foundation that survived the flood, a foundation they attributed to the Anunnaki, the antediluvian sages, the gods who descended to establish order before chaos came, and afterward descended again to restore what had been lost. Networks, not random settlements. When the 5 antediluvian cities are plotted on a map of ancient Mesopotamia, a pattern emerges. They're not clustered together, but distributed across the region. Eridu in the far south near the ancient coastline, Bad Tibera and Larak in the central alluvial plain, Sippar in the north near where the Tigris and Euphrates converge, Shuruppak in the middle zone controlling access between north and south. Together they define the geographic extent of what would become Sumer, positioned to control water resources, agricultural lands and trade routes. This distribution isn't random, it's optimal for a coordinated network. The spacing between cities, roughly 50 to 100 kilometres, allows each city an agricultural hinterland without overlap, while keeping them close enough for communication and trade. Each city controls a section of river access, essential for irrigation and transportation. The north-south spread provides coverage of the entire region, ensuring no major zone lacks urban presence. If you were planning a settlement network in Mesopotamia, you'd place cities exactly this way. Modern urban planning recognizes this as central place theory. cities emerge at locations optimizing access to resources and populations, with spacing determined by economic catchment areas. Large cities space themselves farther apart than small towns, because their economic reach extends farther. The 5 antediluvian cities' distribution matches what urban geographers would predict for a planned regional network, not the random pattern expected from organic settlement growth. Archaeological patterns support coordination. The cities show similar architectural principles, temple platforms facing cardinal directions, standardized brick dimensions, tripartite temple layouts. They use the same measurement systems, the same cuneiform script when writing develops, the same religious iconography. They participate in the same trade networks, importing lapis lazuli from Afghanistan, copper from Oman, timber from Lebanon. This homogeneity across distance suggests either political unification or cultural standardization established before the cities developed independently. The Sumerian king list sequence, kingship moving from Eridu to Bad Tibera to Larak to Sippar to Shuruppak, might reflect the actual founding order. If so, we're watching network expansion, establish Eridu in the far south, then move north to found Bad Tibera, continue the pattern through Larak and Sippar, with Shuruppak last, positioned to integrate the network. Each new city founded from the previous one would naturally adopt its standards and practices, creating system-wide consistency. The astronomical dimension reinforces this. The cities span 4 degrees of latitude, sufficient to provide different observational perspectives on the same celestial phenomena. An astronomical event, a planetary conjunction, a lunar eclipse, a comet would be observed from all 5 cities at slightly different times and angles. By comparing observations, ancient astronomers could triangulate positions and calculate distances, the same technique modern astronomy used before satellites. The 5 cities weren't just urban network, but observatory network, positioned to enable sophisticated astronomical measurement. Temple orientations show this most clearly. Sumerian temples consistently aligned to cardinal directions, determined by astronomical observation. The precision varies. Some temples align within 1 degree of true north, others within 2 or 3 degrees, but the intent is clear. Why did alignment matter? Practically, it standardized architecture across the region, ensuring temples shared common orientation regardless of local terrain. Symbolically, it connected earthly structures to cosmic order, the temple as axis mundi linking heaven and earth. But achieving precise cardinal alignment requires observational skill, specifically tracking the sun's shadow or circumpolar stars' movements over time. If temples in all 5 antediluvian cities aligned to cardinal directions using the same observational methods, they were following shared protocols, evidence of coordinated practice, not independent invention. The protocols had to be taught, transmitted from city to city, maintained by trained specialists. This is precisely what the Apkallu tradition describes: sages travelling between cities, teaching arts and sciences, establishing standardized practices. Whether the Apkallu were literally semi-divine beings or simply trained specialists, their function in the text matches what the archaeological evidence suggests: knowledge transmission creating network-wide standardization. The city names themselves might encode functional information. Eridu means good city or mighty city. Bad Tibera means fortress of the copper workers, indicating metallurgical specialization. Sippar means bronze city, also suggesting metalworking. Shuruppak possibly derives from Shudurak, meaning the place of great peace, though this etymology is uncertain. If cities were founded with functional specializations, Eridu as administrative/religious center, Bad Tibera and Sippar as metallurgical centers, Shuruppak as trade hub, the network would resemble a distributed economic system, each node contributing different specialization while sharing common cultural framework. This is speculation beyond direct evidence, but it fits the pattern. Complex networks require coordination, specialization, and standardization, exactly what the archaeological and textual evidence indicates. The alternative is that 5 cities independently developed identical measurement systems, identical astronomical practices, identical religious frameworks, and identical architectural principles while remaining politically independent, which seems far less likely than coordinated development from. Common source. The source, according to Sumerian tradition, was the Anunnaki and their agents, the Apkallu, who established cities according to divine plan. Strip away the mythological framing, and we're left with planned urban network established by knowledgeable specialists using advanced understanding of astronomy, geography, and engineering. Whether those specialists were indigenous Mesopotamians, immigrants from elsewhere, or something more unusual, their achievements were real and their legacy profound. After the flood disrupted this network, the knowledge survived and new cities emerged: Kish, Uruk, Ur, Lagash, continuing the patterns established by the antediluvian cities. The continuity demonstrates resilience, the successful transfer of knowledge through catastrophe, and that knowledge continued to develop. Sumerian astronomy became Babylonian astronomy, eventually transmitted to the Greeks, forming the foundation of Western astronomical tradition. The sexagesimal number system survives today in our measurement of time: 60 seconds, 60 minutes, and angles 360 degrees. The ziggurats inspired temple architecture throughout the Near East. The 5 antediluvian cities were beginning, not endpoint, the founding nodes of civilization that spread across Mesopotamia, influencing surrounding regions, ultimately shaping the course of human history. Their pattern of planned coordination, astronomical sophistication, and knowledge preservation established a model later civilizations followed and built upon. The Sumerians themselves credited the Anunnaki. We credit human ingenuity. Perhaps both deserve recognition: human ingenuity preserving and developing knowledge that came from somewhere, transmitted by someone, established in cities whose placement suggests planning that anticipated centuries of civilizational development. The question that remains: the planisphere K8538 rests in its climate-controlled case, its cuneiform marks as crisp as the day they were pressed into clay. The 5 cities lie beneath Iraqi soil, some excavated, others waiting. The astronomical tablets stack in museum archives, their calculations still accurate after millennia. And the question remains: what were the Anunnaki? The evidence permits multiple interpretations. They could be gods in the literal sense, supernatural beings who established civilization, exactly as the texts claim. They could be myths, invented to explain civilization's origins through religious narrative. They could be distorted memories of historical figures, perhaps foreign traders, perhaps indigenous innovators whose achievements were mythologized over centuries. They could be symbolic representations of natural forces, celestial bodies, or psychological archetypes, given narrative form in human imagination. Each interpretation has merit and limitations. The literal divine interpretation requires accepting supernatural intervention in history, which falls outside scientific methodology. The pure mythology interpretation struggles to explain why geographic and astronomical data is accurate while dismissing the explanatory framework as fiction. The distorted memory interpretation is plausible but speculative, lacking direct supporting evidence. The symbolic interpretation reduces complex narratives to abstractions that might miss historical content. What's undeniable is what the Sumerians left behind: cities planned with precision, temples oriented to celestial positions, astronomical observations recorded systematically, measurement standards maintained across generations, and texts insisting this knowledge came from before the flood, transmitted by the Anunnaki through their servants, the Apkallu. We have the results. The achievements are tangible. The question is the source. Modern civilization operates similarly. We inherit knowledge systems we didn't invent. Mathematics, astronomy, physics, building on foundations established by predecessors. We know Newton, Einstein, and others contributed. But the average person using GPPs doesn't understand general relativity. They simply use technology built on knowledge transmitted through institutions. If modern civilization collapsed and survivors rebuilt centuries later, they might remember the ancients who understood the stars without precise knowledge of who those ancients were or how they achieved their understanding. The knowledge would survive in simplified form, its origins mythologized. The Sumerians might be our mirror image, inheritors of knowledge from predecessors whose identity became mythologized because the catastrophe that nearly destroyed them also destroyed precise memory of who they were. The Anunnaki might be real people, real achievements, real knowledge transmission, encoded in mythological language, because that's how the Sumerians conceptualized their heritage. Or the Sumerians might be precisely what their texts claim, recipients of knowledge from the Anunnaki, beings whose nature we don't understand, but whose influence was formative. The texts are clear, consistent, and specific. Dismissing them requires assuming the Sumerians were fundamentally confused about their own origins, that their astronomers were brilliant, but their historians were fabricators, that their technical precision didn't extend to historical accuracy. The tension between these interpretations defines the mystery. We have evidence but not proof, patterns but not certainty, texts that might be history or mythology or both. The Sumerian sky maps show knowledge that needed to be gathered systematically over time from multiple locations. The city network shows planning that anticipated long-term development. The flood narratives show civilizational disruption and recovery. The Anunnaki narratives show knowledge attribution to non-human or superhuman sources. You've heard the evidence tonight. The astronomical tablets are real. You can examine them at the British Museum. The cities existed. Their ruins dot the Iraqi landscape. The flood disrupted the Gulf region. Geology confirms sea level changes. The knowledge systems were sophisticated. Measurement standards and astronomical calculations demonstrate extraordinary precision. All of this is verifiable fact. What remains unverifiable is the Sumerian explanation that the Anunnaki descended to establish cities, that the Apkallu taught civilization, that knowledge predates the flood, that what appears sudden in the archaeological record was actually recovery from catastrophe. These claims can't be proven or disproven from available evidence. They remain in the category of historical possibilities, perhaps true, perhaps mythologized, perhaps misunderstood, but not definitively answered. The scientific method requires provisional conclusions subject to revision as new evidence emerges. The current consensus treats Sumerian civilization as independent development, the Anunnaki as mythology, and the flood as embellished memory of local flooding. This consensus is reasonable given available evidence, but it's provisional, not absolute. Underwater archaeology in the Persian Gulf might reveal submerged settlements predating known Sumerian cities. Climate studies might confirm catastrophic flooding in the period Sumerians described. Genetic analysis might show population movements indicating immigration from elsewhere. Or none of these things might emerge, confirming current consensus. The value in examining these questions isn't reaching definitive answers, but maintaining intellectual honesty about uncertainty. We don't know everything about human origins, ancient civilizations, or the development of knowledge systems. The gaps in our knowledge are substantial. The Sumerian texts fill some gaps while creating others. They answer questions about how Sumerians understood their origins, while raising questions about whether their understanding was accurate. What we can say with certainty is that Sumerian civilization was remarkable, appearing with advanced technologies, creating knowledge systems that influenced all subsequent Near Eastern cultures, recording their achievements in durable clay tablets that survived millennia. They were observers, calculators, builders, and thinkers of the first order. Whether they were also accurate historians, preserving memories of the Anunnaki, or mythmakers creating foundation legends, or some combination of both, their legacy remains. Our civilization built on their foundation, using their sexagesimal mathematics, tracing our astronomical knowledge to their observations, standing in continuity with the tradition they established. The mystery of the Anunnaki might never be fully resolved, but the question itself is valuable. It reminds us that history has depths we haven't fully explored, that ancient peoples knew things we're still rediscovering, and that the boundaries between history and mythology are less clear than we often assume. The tablets remain, waiting in museum archives, ready to yield more insights to future researchers with new questions and new methodologies. For now, the stars still trace the paths the Sumerians mapped. The cities still mark the places they built, and the knowledge still flows through generations, transmitted from ancient observers to modern scientists, linking us across millennia to the beginning, whenever that beginning was, whoever established it, and whatever the Anunnaki truly were. Rest with that question. Let it settle into the spaces between waking and sleep. The answer might come in dreams, or in dawn's first light, or in patient years of scholarship still ahead. For now, the mystery endures, as ancient and enduring as the clay tablets that preserve it.